There will still be people coming in.
In front of the cinema, so I think
Ale co, my jedziemy już, nie? Żeby tam nie...
I would get dizzy and nosebleed.
So, hello, good morning and welcome. My name is Rafał Motriuk. I'm a science and technology journalist, also a lecturer at our local SWPS University and co-owner of Intercom communications company, and I'll be your host today and tomorrow here in room 1. Our conference is called Code Dive and it is now officially open. Now, our city here is the heartland of Poland's IT business, and it is also known for its impressive number of bridges, currently around 130, and we have even more impressive number of friendly city gnome statues, you know, those little thingies, and there are almost, 400 of them in our city, and Nokia's got its own, and it's called Nokius. Everybody, welcome to Wrocław! I'd like to welcome everybody gathered here in the New Horizons cinema, and I'd like to welcome everybody watching online. I asked the organizers, what our partner countries are where they can actually watch us live, and the answer I've got is, all over the world. And it's the 6th time that Nokia has organized Code Dive for us. And can I just ask by show of hands, for whom is this the first time? Okay, a lot of people. Second time? Third? Fourth? Fifth? And sixth? That's what I call devotion. Thank you very much. Sixth time here. And over those 6 years, Code Dive has become perhaps one of the most influential conferences of this sort in Central Europe. This year, a record 1,700 people have signed up for this conference, and we've got 4 rooms and dozens of lectures to choose from. And this year we've got a lot of brand new speakers, and they come from so many different countries, including Bulgaria, Canada, France, Germany, India, Sweden, Spain, Russia, US, Ukraine, and of course Poland. And we all gather here in Wrocław, and the city's motto is the meeting place, and I do actually believe it's the meeting place. And if it is so, may I just ask for the regular first round of introductions. So on my count, I'd like everybody to say their first name. That's on 1. On 2, the name of your current employer. And on 3, the name of your favorite programming language. So in my case, it would be 1, Rafał, 2, Intercom, 3, Python. You ready? Breathtaking enthusiasm. Thank you. So, 1, 2, 3. I can hear C++ are in a majority. Okay, today's conference, just for everybody to be clear, is free, and yet the quality of talks is top. So may I ask everybody to join me and thank our sponsor and organizer, Nokia. As usual, very briefly, just some house rules, so I'll start with the boring usual. If I may ask everybody to please mute your phones. If you have any questions for the speakers, this year we decided to do something a little different. So if you've got a question after the talk, and yes, please park your questions until Q&A, we would like everybody to gather here, these stairs over here, just form a nice queue after the talk, and then you'll be given a mic, and then you can ask your question so that the whole room and people watching online will be able to hear you. Don't worry if you miss a lecture All of the talks are recorded and then they will be available on our website. And on the website you can also comment and rank the talks. Lunch break is between 1 and 2. There is no service provided here in the venue, but there are a lot of reasonable places within a walking distance, so basically everybody needs to get their own food. Today we'll be finishing at 6 p.m, but an hour later at around 7 in Szklarnia Cocktail Bar, we've got what we call a middle party. It's just a few blocks away, so feel free to join us for more informal chats. And we've got a partner this year, the publishing house called Halion, and just outside our room 1 they are offering some books, so feel free to visit them and get some books for yourselves. And now I'd like to give floor to Bartosz Ciepluch, who's head of Nokia's Wrocław Technology Center, for his opening speech. Bartosz Ciepluch.
Okay, good morning everybody. So this is for me 6th time and they are still inviting me for opening this code dive. But before I open this officially, I would like to have a small reflection about the very sad situation that was happening on the last Thursday. Maybe some of you are aware that one of the employee engineer who was planning to, of course, come for the code dive was dying on the Thursday, so Piotr, in the accident which was happening in the shooting range, which is 1 kilometer from here. So just to respect him, I propose that we will stand up and respect him with the 1 minute of the silence. Okay, thank you very much, and I hope that Piotr is hearing us also today. So, code dive. Very special event, 6th time, and always bringing a lot of the nice speeches. We have speakers from Nokia, we have speakers around the world, as Rafał already was mentioning. But as usual, at the opening, I would like to really mention, how the code dive is built. This is not the event that Nokia is buying from the other company, from some agency, or the people from the external are behind that. So everything is coming from the bottom up. So there are passionate people who are working on the code dive for the full year, thinking who should be coming and what there should be the topics. A lot of the passionate people are delivering this to you. But I would like to really thank, with the names of the Adam, Marcin and Michał, who are really behind the conference this year. And I would like to have a big applause for all of the people who are behind the code dive. So big applause, please. Whenever I was thinking about the code dive, this is, one of the base for the first code dive was that to build a platform for the Wrocław IT community, that then, of course, it was extended to the other sites and the other places, but the platform in which you are able to have a really good technical talks. And this is working very nice. But then, you have some gift coming out from the code dive that, you can refer to the YouTube videos with the lectures, but then we were also thinking, how to take the code dive into the packet. And one of the really, nice thing which we are also doing in Nokia, in Wrocław, is this book. It's called the Nokia book. And this is quite, fat book that you have plenty of the pages of the technology. We are releasing this every year. So this what you are seeing is the 4th edition and the 5th edition is just coming. But, the engineers from the Nokia writing the articles, I would say about the cutting edge technology. Many of the articles that the people are putting in this book are not able to be found anywhere. The universities are coming for us, to get these books. And, this is something which was also coming from the spirit of the code dive. So I really encourage you that whenever you are finishing these really fruitful 2 days, you know, you will be having plenty of the talks, you will be having plenty of the discussions, which is really, really important. Do not forget also about that there is a code dive in the packet, which is called Nokia book. And you can download the versions, electrical versions from the internet, from the GitHub, where all of the books are storing. And the last but not least is that, you know, it's coming the 5th edition of the book very soon. It's talking everything about the machine learning. So if you are interested, just stay tuned up for this release, which will be coming very soon. So just to making the closing, you know, I really wish you the very fruitful 2 days, good discussions, and, you know, I wish you enjoying the code dive. So thanks very much.
Thank you, Bartosz. So, time for our first talk of the day, and it will be delivered by Barbara Geller and Ansel Sermersheim. Barbara's primary work involves software development for Copperspice, and that's consulting, product management, and educational trainings. She has been working in the software industry for over 25 years, and her degree is in electrical engineering from California State Polytechnic University, with additional studies towards computer science. She has worked with a variety of companies on custom applications, in addition to developing Windows applications for several vertical markets, including medical billing, transportation, and construction. And Ansel Sermersheim is a consultant specializing in the development of the Copperspice project, promoting open source and educational trainings. He has been working as a programmer for over 20 years, and his degree is in computer science, also from California State Polytechnic University. And they have both taken part in so many meetings of ACCU, and that was in San Francisco Bay Area, but also in Amsterdam, Munich, in London. And basically they say that if a programmer tells them that something is impossible, they will find a way out. So they're ready to accept your challenge if you think something is impossible, and they'll do it no matter how many variadic templates is required. And I'll tell you a secret. This is the largest room they've ever spoken in. So let's have a big hand for Barbara Geller and Ansel Sermersheim.
Welcome and thank you for coming. Do we have microphones on at this point? So you can hear me at the back? Excellent. Undefined behavior is not an error. And the title of this talk is really important because errors are one thing and undefined behavior is something else. Okay. Oh, now you can hear me. I can hear the echo. Excellent. So let's get going. Oops. I think the microphone has actually broken at this point. Oh. Sorry for the slight delay here while we figure out what's going on. Ah, perfect. Okay. Little technical stuff is always exciting. So as we begin our presentation, we're going to talk about what undefined behavior is, because you can't reason about undefined behavior if you don't have a definition. So we're going to be talking about a lot of terminology, and we're going to talk about why it's not an error, and we're going to give you some ways to look at undefined behavior. Before we begin, we want to tell you who we are. Ansel and I are the maintainers of the Copperspice project. And Copperspice is a set of cross-platform C++ libraries. In addition to Copperspice, we've also developed several other standalone libraries. One of the things I wanted to point out is DoxyPress. DoxyPress is a derivative of Doxygen. So if you're doing documentation, which you should be, then DoxyPress is something you want to take a look at. It documents not just C++, but several other languages in a variety of outputs. And DoxyPress actually uses the Copperspice libraries.
One of the founding principles of the CopperSpice project is that everything we do is open source. So all of our libraries and projects are available on GitHub and through our download site, and we do our best to use the very latest in modern C++ technology with everything we do.
We did want to mention that as an open source project, although we are the co-founders, we have amassed several people who have joined the product and work with us. If you're looking for an open source project, we absolutely encourage you to take a look at CopperSpice and the various libraries we have and come and join us.
One of the reasons we wanted to give this presentation is because there are many wonderful presentations about undefined behavior, and you should totally watch them. But most of them are written from the viewpoint of a compiler developer, which is really interesting and fun. But then you get done watching it and you say, but how does that actually teach me what I need to know to write good code? Many of them don't. It actually turns out not to be as helpful to study the compiler, to learn about what we need to know as programmers to avoid undefined behavior.
So what do programmers believe about undefined behavior? Well, the compiler should just fix all my undefined behavior. That's not true. It's not going to, and it's not designed to. Hey, undefined behavior, not my job, somebody else's job. That's not true. As a developer, it is your responsibility to pay attention to undefined behavior. And we're going to explain why you can't do it. You must avoid undefined behavior in your C++ applications. So part of this talk is, what do we need to learn so we can recognize undefined behavior? And then how do we start avoiding it?
So first we need to cover some definitions. And these are right from the C++ standard. These are terms that are specified. For example, defined behavior is code which has a single prescribed meaning in the standard. If you have a line of code that says int sum equals 5 plus 2, and at the end of that line, you don't have a variable named sum which contains the value 7, your compiler's just broken.
If there's a printf and it doesn't actually do what a printf is supposed to do, please report it. That's not okay. So defined behavior is a term that says, this is defined to do this thing. And that is actually what it needs to do. Implementation defined behavior, that's a little different. This is code which has multiple meanings, but the compiler has to pick one, and it has to document it. So with implementation defined behavior, you will know on a particular platform exactly what the result would be.
So for this example, we're asking the question, is the size of an int less than the size of a long? Well, that's certainly a reasonable question to ask. It has to be either true or false. And for a given platform, it will be consistent every time you compile your program.
Unspecified behavior, that's a little different. This is code which has multiple meanings, and the compiler can choose one. On every compile, it could change what it does.
So in this example, we're comparing two string literals. And this sort of looks like a string comparison, but it's not. It's actually comparing the address of these two string literals and asking, do they live at the same location in memory? Now, the compiler is allowed to put these in the same location because they are the same contents. But it can choose based on no reason at all. So for any given run of your program, this will either be true or false, but it's completely unpredictable.
Then there's undefined behavior. And this is code which has no meaning. Dereferencing a null pointer, you're lost then. It just doesn't have a meaning. You can't reason through it. Accessing an object after it's been destroyed. Could be interesting, could be nothing. You don't know. So undefined behavior has an actual meaning according to the standard. But its meaning is that code has no meaning.
Now there's a couple of terms that we wanted to talk about that are not found in the C++ standard. But they're relevant here because this is what we actually care about as programmers. First, there's the idea of a valid error. An error condition is something that might happen during the execution of your program that you didn't want, like some file you intended to read from doesn't exist. That's an error. Or you're out of memory. Maybe you passed an invalid argument to some function that does check its input parameters. These tend to cause things like assertion failures or exceptions, or you get a result code that says this operation failed. The standard also doesn't talk about the idea of intended behavior. I mean, obviously, as programmers, that's what we want. The program did what we hoped it would do. But as far as the standard is concerned, there's no difference between an error and the behavior you wanted. Both of them are just the result of executing your program according to the rules of the standard.
So what is undefined behavior? It is the result of attempting to execute source code whose behavior is not defined in the C++ standard. It is your responsibility to write code which never causes undefined behavior. The definition of a correct program, it's free of race conditions, it's free of undefined behavior. This isn't asking whether some result you're calculating for your client. It's not looking at that to say, did we get the right answer? This is about saying there's no undefined behavior. And the point about undefined behavior is you can't do it. It is your job, and we're speaking in C++, you must avoid it. And that's a really important point, and frustrating to some, because some people say, can I have a little? No, there's no amount you can have. So operations which fall under this umbrella of undefined behavior, you have to get rid of them, no matter what it takes. So let's take a look at a funny and silly example. I have a really good chocolate cake recipe. It's actually wonderful. It's a recipe. And the ingredients are specified in this recipe. The recipe also says if you want to put walnuts in, go for it. You can leave them out, you can put them in, the cake will be perfect. But the recipe calls for 1 teaspoon of salt. And for conversion, a cup of salt is about 50 times more salt. I can guarantee you, if you put in a cup of salt, the cake will be awful. It will just be not a cake you want to eat. But here's the catch. The salt is an error, but this makes the entire cake undefined behavior. Not just the salt. And that's why we've chosen this sort of silly example about a cake. Just because the salt is the problem, it is the entire cake. It could be just anything.
The other factor to consider when you have undefined behavior in your program is sometimes it does what you expected it to anyway. If you take this recipe and you substitute soy milk for milk, you will still probably get a cake. It will mostly work. But still you're in undefined behavior because you're outside the constraints of what the recipe prescribes.
Hang on, I'm coming. What's a talk without a little technical problem? So this is about the idea that programmers think undefined behavior, oh, that's easy. We had somebody tell us, I know undefined behavior isn't good, I just won't do it. Fine, I've solved the problem. But it's hard to find. And what about the rare crash? How often have you had a program that crashes once in a while? And you're like, well, I'll get to it later. It's not that big of a deal. It is. Undefined behavior, you need to get rid of it. That's what we're here to tell you.
And this is particularly important if you're writing code that's going to accept untrusted input. If you're writing a web browser or a server or any sort of network daemon, you must ensure your program is free of undefined behavior. The vast majority of security holes that we encounter in the wild are the result of some kind of undefined behavior being present in some system that's accepting unsafe input.
So here's a list. It's not a complete list, But take a look at it. See if you recognize some of the things that you have encountered in your code. Dereferencing a null pointer, have you done that? Do you access uninitialized variables? These are undefined behavior. This is what we need to start getting rid of. And this list is, like I said, it's a partial list, but it's the very common list.
So these are sort of the top favorites in the undefined behavior world. But if you go and look at the standard, you won't find this list anywhere. It's spread throughout the whole document. So you really need to be familiar with the pieces of it that you're using to know what's dangerous.
For those of you who do template programming and you're used to Undefined, we came up with Undefined. That is, undefined behavior is not an error. We thought it was an interesting name. Because undefined behavior has a very specific meaning. Something which defined as an error, that's not undefined behavior.
One of the ways we like to look at this is an error actually produces some well-defined result. It's an error status, but you can handle it. You can trap it. You can take some corrective action. You cannot handle undefined behavior. By the time it's happened, it's too late. Your program is in an undefined state, and there is absolutely nothing you can do. So there's really three different kinds of things that can go wrong. There's compile time errors. We do that all the time. We fix it, we recompile the program, and we get an executable. There's runtime errors. We have to put in logic to deal with those. And then there's undefined behavior, which you just have to avoid. There is no other option.
If you could back up, thank you. So this example of my vector at 10. So we're saying that we have an STD vector of 5 elements. Calling the 10th element, this isn't something you can do. This is undefined because of the at. Because if you're calling that method, that is undefined behavior. You have to avoid doing that, which means you need to do testing to make sure this doesn't happen.
So one of the ways to look at this question of undefined behavior is to look at the compiler a little bit. And we're looking at the compiler of the future. We call it EC because I'm a really efficient compiler. And I know you're a really good programmer. And so I know you didn't put any undefined behavior in your program. So if I find some, I just know that you didn't mean to do that, so I'll throw that code out because it'll never happen. I'm a great optimizer.
I'm the evil compiler. I see your undefined behavior. I'm going to zero things out. I'm going to get rid of code. I am going to do things you never thought possible. And I am truly evil, and I will surprise you all the time.
So depending upon your point of view, compilers are either evil or efficient. If you understand how they work, they're very efficient. Your code will be great. If you don't understand how they work, you'll be fighting with them all the time, and they'll keep messing up your code. Now, compilers are pretty simple when you turn off all optimization. So when optimization is off, the compiler just literally translates your code exactly the way you wrote it. So undefined behavior usually doesn't manifest in any form. You can't see it because it's really executing your code one instruction at a time in order. But when you turn on optimization, the compiler does a lot more thinking about what your code means. And if there's a section of code that's meaningless, it's discarded. The compiler doesn't have to tell you about this, and there are a lot of fundamental reasons why, in many cases, a compiler couldn't tell you about this because it can't even know that it's done this. So, as a general rule of thumb, if you have code that works when you turn the optimizer off, and it breaks when you turn the optimizer on or upgrade to a new compiler, you have undefined behavior somewhere in your code.
So as a quick recap, we have defined behavior, implementation defined behavior, unspecified behavior, and undefined behavior. And these are 4 different categories. We want to make sure it's really clear to everybody. Defined behavior, that's what you want. Undefined behavior, you need to get rid of it.
And the categories in the middle, you should pay attention to because they might behave differently on different compilers.
So let's take a look at an example. I know it's a little hard to see. This is the point where everybody gets to shout out things, because we like the little participation. What's wrong with my function over here? It doesn't return anything.
That is true.
It looks kind of okay, but there's no return statement. This is undefined behavior. What's really going on at the compiler level is usually, not always, but for most of the time, this code will start executing until it finds a return in some other function or method, which may return a bool, may not. The truth is, this happened in some of our code. We knew we were getting some bad results. You've got thousands of lines to look at. You don't even know where it is. We actually stared at it going, that looks pretty simple. I mean, it took us about 10 minutes to realize the return was missing. There are warnings you can turn on to alert you of this. But this is a bit surprising for some people, that it's not just that you get an error. It is that it will find a return line somewhere in the assembly code somewhere later.
Here's an example from some code that we worked on several years ago. So we have an access to an element in a container that's out of bounds. And in this case, we're using operator square brackets, which exhibits undefined behavior if the index is invalid. Now, this is using a version of the QString class from several years ago in CopperSpice. And at that time, QString didn't guarantee null termination. So let's walk through what this for loop does and why it has some interesting undefined behavior. The purpose of this loop is to find a colon in the name of a class, because we want to find the actual class name in this string. So we're walking through character by character, and we're looking for a place where the next character and the character after that are both colons. If we find that, we stop, we're done. Except this didn't work. We tried it over and over. We tried debugging it. It just didn't work. The compiler was quite smart here, or evil.
Actually, it was evil. It was quite evil.
This loop has undefined behavior on the last two iterations, because on the last two times through the loop, you're indexing off the end of the string. So the compiler says, well, if I ever get into the loop, there's certainly going to be two last iterations. And since that's undefined behavior, I know you didn't mean that. So the only way this code is valid is if the input string is always empty, so we don't get into the loop. Therefore, the input is always an empty string. Therefore, the output is always an empty string. We're done here. I made your code way more efficient, didn't I?
It was one line. It returned empty string. It said, nope, I can never find this. The problem is, it's really hard to debug this, because you can't just jump inside the compiler and say, what do you do? But we noticed that no matter what input string we had, the output was nothing. Since then, we have changed CopperSpice, we have null termination, we've optimized this, but we learned a lot from this. So this is an indication that the compiler is free to say, I'm never executing this code because undefined behavior couldn't have existed.
Now here's an example to show you how challenging it can be to read the C++ standard just to determine the answer to the question, is this undefined behavior? So here we have a really small program that just declares two variables and then compares their addresses. Now, there's a line in the standard that says relational comparison of pointers is only defined if the pointers point to members of the same object or elements of the same array. Are either of those true here? Well, no. A and B are just two unrelated variables on the stack. So it kind of sounds like comparing them with a less than operation is undefined. Now, this is kind of weird because comparing them for equality, you definitely should get the answer false because these are two different variables. They have to have different memory addresses. Well, it turns out that there's another paragraph somewhere else in the standard that says anytime you compare two things and the comparison is undefined, the result is unspecified. So even though it's an undefined result, it's actually just, you don't know whether it's going to be true or false. So this program has no undefined behavior. You just don't know what it will return.
This actually resulted in a defect report in the standard. It's a small one, but we're kind of impressed that we were able to actually draw it to their attention that the wording in the standard was a little bit vague.
Here's an interesting example that is from the Clang team. This is a function that simply sums the first n numbers. And so we have a for loop here that just adds up all the numbers from 0 to max. Now, if you compile this with optimization on in Clang, it actually recognizes that this is summing the first n numbers, and it uses Gauss's formula to eliminate the for loop and compute this in one arithmetic operation. So that's kind of neat. The reason the compiler is allowed to do that is because of undefined behavior. Because if you pass too large a value into this function, then the arithmetic would overflow. And in the overflow case, the answer you get from Gauss's formula and the answer you get from this loop are different. So doing that optimization would be a bug, but the compiler knows you will never pass a value that's too large to this function, right? You promised. And if you play around with the constants here, the compiler actually rewrites the formula so that the ranges exactly match the value you should get. It's a very intelligent part of the compiler.
So here's another example which catches a few people. Do things 6 takes a const reference, nothing that unusual. It does it const cast, and that's the way you would say, I know I received something as a const, but I want to change it, so I'm just going to do that. Looking at this code, there's nothing wrong with it, but there is. It depends on how the original declaration was made. Now, where is that original declaration that is passed to do thing 6? I'm not sure. But if it was declared as const, received as const, it is undefined behavior to const cast this. That is tricky code to me, because now this code is dependent on how it was called, which may be 3 or 4 functions or methods before where I'm at. We've had people say, I do this. I never thought about it. This happens to be undefined behavior.
So this function and the one on the previous slide are instances of an interesting idea. These are functions that have undefined behavior for some inputs. And the question is, how do you document, or do you document, which input values in your functions produce undefined behavior? Because if you have functions like this, you need to. Now, there's another piece of undefined behavior, and this is an example of undefined behavior that occurs at compile time. Now, that's kind of weird. The standard says specializing a type trait that exists in the std namespace is undefined behavior. And the reason for this is, if this were allowed, I could specialize the isPointer type trait for int and return true. Now I've said that ints are pointers. That doesn't make any sense.
This would not be a good idea.
It's clearly going to mess up all sorts of template code in the guts of the standard library. So this is simply undefined behavior. But no compiler actually diagnoses this. You'll never get a warning on it.
We're not saying that you can't define your own type traits. We're saying you don't want to overload a type trait that's in the std namespace. So this is an interesting idea. You're writing a program. You want part of A to happen before B. That's why you're writing a program. It has a flow. Something is supposed to happen, then something else. If the compiler just said, I'm just going to throw it all together and do it all at the same time, that's not going to work. You're not going to have the result you're looking for. This idea that things have to actually happen in a given order is the idea of sequencing. And by studying sequencing, now we have a way to reason through undefined behavior. And it's also going to lead to more readable code.
It's also really valuable to understand the concept of sequencing, because if you're ever going to do multi-threaded code, sequencing is very fundamental to understanding atomic operations and synchronization between threads.
Before we actually talk about it, we need to define what a side effect is.
So an expression is said to have a side effect, and this is a generic computer science term. This is not C++. A side effect just means it changes the state of your program in some way. So changing the value of a variable that already has a value is a side effect. Now in C++, certain things are not side effects, like returning a value. That doesn't actually change anything. It's just a new value that's available.
Slide over here
Or
so they can see the slide.
a statement which declares and initializes a variable at the same time. We don't look at that as being a side effect because the variable is sort of considered to be born with that value. Nothing changed at that point.
So on line 1, how many side effects do we have based on the definitions we've just explained?
Anybody care to shout out an answer?
0? Anyone with 1? I'm not hearing a 1. It is 0.
Good crowd.
Excellent.
You guys are paying attention.
It's 0 because we have a declaration. And doing arithmetic, adding the 8 and the 5, that doesn't make a side effect. So what about on line 2? How many side effects? I'm hearing just 1? 0? So we have 0 and 1.
The correct answer on this is 1. Because var b has some value before we get to this line of code. It's undefined what the value is, but it had some initial value and now we're modifying it. So there is one side effect on this second line.
So let's take a look at lines 3 and 4. So this list here of these 4 things, this is not a partial list. This is actually the complete definition. These are the actions in C++ which produce a side effect. So only 4 things.
And it's a pretty short list, so you can memorize it. And it's kind of logical. Reading a volatile object is a side effect. That's the meaning of volatile. It means accessing the variable in any way is a side effect. Writing to any object is a side effect. Or doing I/O, that makes sense because something appears on the screen or on a network terminal or what have you. Or calling any function which does one of these. Well, that kind of makes sense. If the function has side effects, then calling it is a side effect.
So how many side effects on line 3? 1?
I hear some ones.
I'm sorry? Unknown? Well, we're assuming that var A was declared on the previous slide. So var A and var B are nice and declared. So by doing this assignment,
We have one side effect.
one side effect. How about line 4? 3. 2. This is fun. Anyone for 0, 5, 12? Okay, good. Just make sure everybody's awake. Does anybody want to shout out how they worked it out? I can see about the first 4 rows, and that's it. So you're saying it's 2?
And there's a modification of var A and a modification of var B, I heard. So you're absolutely correct. We're decrementing var A, that's one side effect, and we're assigning a new value to var B. That's a second side effect. The addition of 2, that's not a side effect, and we're not, and that's all there is on this line.
So there's 2 side effects. Okay, so sequence points. A sequence point, this has been around since the beginning in C++. Sequence points are, as I'm going along, things are happening. At this point, everything prior, that's all been done. And I haven't started anything new. So the idea of a sequence point is at a particular point, the compiler knew, that's all done, this is pending. So there's the option in the compiler to rearrange code. And this is why compilers are so darn interesting, is how does it know where it's safe to rearrange code?
So the answer, if you're looking at sequence points, is between two sequence points. The compiler can rearrange the code any way it likes, but it can't reorder code across a sequence point boundary. And so this is the way they were defined in the standard. At that sequence point, oftentimes the semicolon, everything before it had to be finished, including all of its side effects, and nothing after it could have started yet. This is sort of a reasonable way to think about programming. And sequence points have been part of the core language. We actually inherited them from C. They're a very old concept. But they're gone.
C++11 changed it. It wasn't a good definition. Again, it was inherited from C. So as of C++11, sequence points were eliminated from the standard. The term is now sequencing. I do say it with that effect and the ing, because the ing ending becomes really important to that word.
So with the sequencing idea, sequencing is really a set of relationships on the expressions in your program. So we can ask, of any two random expressions, what is their sequencing relationship? A can be sequenced before B, which is the same as saying B is after A. That's reflexive. They can be indeterminately sequenced, which means one of them happens first and then the other, but you can't guarantee which. And then there's unsequenced, which means the execution of these two expressions can be interleaved. Parts of each one can be happening simultaneously or overlapping.
So here's another example, more audience participation. If two side effects or a side effect and a read occur on the same object and they're unsequenced, you have undefined behavior.
Okay, so sequencing is connected to undefined behavior, isn't it?
Yep, that was the idea. Pre-increment. What's happening on this example? Are these undefined behavior? So I heard a no on just A or A and B. So A, that one is defined behavior. Okay, we got a thumbs up.
So by a show of hands, who thinks A has defined behavior?
I'm not sure that's winning.
Who thinks it's undefined?
Who thinks it's undefined behavior? Okay, we have definitely some people that are saying it's undefined behavior. Because we're looking at the number of side effects and whether it's unspecified. Okay?
So let's look at the answer for A.
Problem is it depends on what version of C++.
Before C++11,
Yeah. In 03, I know we're standing a little bit in front of the slides, but in 03, it's just undefined behavior.
and
In
the
11, it's defined.
because in 03 we didn't have sequencing yet. And the only sequence point is at the very end of this complicated statement. So we have no ordering between the operations. In C++11, the pre-increment is guaranteed to occur before the assignment. So this is well defined. And if your compiler doesn't give you the answer 8, it's broken.
So now that you've seen that, how many people think that B is undefined? Not that many. And that it's nice and well defined?
Okay, people are much less sure now.
Oh yeah, we got everybody a little bit nervous. Well, guess what? It depends on the compiler and the version of C++. And we're going to try to back out here just so you can see the slides. This is a post increment, and in 03, undefined. This is undefined behavior in C++11.
The rule that makes this well-defined wasn't added until C++17. So the sequencing section of the standard keeps getting refined as we add new rules to the language to constrain the way the compiler can reorder expressions. So now, in C++17, this does have a well-defined answer.
The problem with why this was undefined has to do with the post increment and the side effects and when they are done. And there are various sections of the standard. If you want to know the exact sections, we can get you that information it's a lot of very complicated stuff to read, but this is the understanding of it, is that, again, in 11, it is not defined because of the post increment. They were missing some terminology.
Now, I'd like to take a moment here and mention that this is the reason why you should not write code that is this tricky, because the behavior on different versions of the compiler will be different. So we're not advocating that you write code like this, but it's important to understand the reason why.
Okay, here's another one. The order of evaluation for pass parameters to a function. This is actually really important. If you take a look at the way this code is written, and again, don't write code like this. We're not advocating it. We are showing this for the purpose of education. Because we have an assignment of var1 from do thing 1. And then notice var1 is passed to do thing 2. To me, this is complicated code to read. And what's the order?
So one place where you get real code that does this sometimes is when you're allocating memory during the call to a function. Don't do this. And here's the reason why. Before C++ 17, this code was flat out undefined behavior because there was no, the evaluation of function arguments was unspecified. So they could be overlapping. So the assignment to var1 could be partially occurring at the same time as you were passing var1 to do thing 2. So that's just undefined behavior. In C++ 17, the order of operations here became indeterminately sequenced. And remember, that means one expression has to happen first, but we're not going to specify which one. So the compiler has exactly two options in this call. It can do the first parameter first, or it can do the second parameter first.
And if the compiler decides, hey, I'm doing option 1, everything's fine, we get the value for var1 calculated, and then it can pass it to var2. But if option 2 is selected, we're back in UB. Now, we had somebody ask us, well, since the compiler knows that option 2 is UB, it'll just pick option 1. Nice compiler. Sorry, I'm quite evil. I'm not going to tell you what I'm going to do, and I don't have to do it to avoid UB, because you promised me, as a C++ developer, you wouldn't have UB. So no, there's no guarantee, there's no settings you can do, Clang isn't going to get better, neither is GCC or any other compiler. In fact, it will probably get worse. So you have to not write code like this, because it's a sequencing problem.
And the reason why this second option is undefined behavior is because we're using the value of var1 before it's initialized. Just thought I'd mention that to make sure everybody got that.
So here's our fun example. Doesn't look very complicated. It's 2 lines of code. There are 5 answers here. I guarantee one of these is the absolute correct answer. The last one is our representation of undefined behavior. So there's a lot of stuff going on. Again, in a code review, nothing that tragic. 4 and 3, I can do that on a bunch of fingers. How is it going to add the 4 and 3? Is it going to get an extra 1 in here, which is possible? And where is it going to save it in the array? I challenge you now to really think about and pick the answer you think is correct. And this is where we take a break.
We just give people a moment
Just
to
give
work
people a
through this
moment.
in their head.
Everybody online, take a moment. So you're saying the second one. How many, and if you're not ready, we can wait. How many for the very first one that it will save it in array element 4? Okay, we've got a
some
few.
votes. What about the second one, element 5? Okay, we've
Couple
got
percent.
several more. That was like 10%.
In 6?
Okay.
Okay, you have to vote. Nobody gets out without voting. Is there anybody who feels unsure about this code?
Yeah, show of hands. Who's
Show
not
of-
sure?
Okay. Well, I
That's-
think we did our job.
That's a really good
That
reason
is
to
good.
turn this down in a code review.
Yeah.
Definitely.
Turn this down, yes. Did we get to the 7?
Who thinks this is undefined behavior?
Yeah, let's go for undefined behavior.
Okay.
I love it.
Excellent. Thank you all for playing.
Thank you for playing. Should we tell them the answers?
Sure, why
okay.
not?
Okay, so let's go through this. In 11, it's undefined.
And the reason why is quite subtle, because every operator has to have its operands evaluated before the operator can do its job. However, the rule in C++11 says the value computations, but not the side effects, of the operands to any operator are sequenced before the value computation of the result of the operator, but not its side effects. Now, that was a little difficult to understand, and I know that.
We added the brackets. We added the but not the side effects. We took the liberty in looking at the standard. Here's where you can find it in 11, because that helps you understand what the standard means when it says value computations.
So be aware that there's two different considerations. There's value computations, which is finding out what value something is, and there's its side effects, and they don't always go hand in hand. In C++11, there's no sequencing rule to determine if the post increment on the left-hand side in the subscript operator happens before the one on the right-hand side. So this is undefined.
So it really is understanding that which happens first, the left or the right. So again, C++11 did not have enough in the standard, so it's just undefined behavior. And it's defined in 17.
So in 17, they added two new rules that prevent this from being undefined. The right side of the assignment, including all of its side effects, is sequenced before the left-hand side, which in turn is sequenced before the actual assignment happens. And if you work through it with that order of operations, you'll get this answer. There's another rule that says the side effects inside the square bracket have to be complete before we access the element of the array. That's also important. So these two rules taken together give this expression a really well-defined meaning.
So we have the 4, we add it to the 3, but we're not done with everything. The question then is, do we increment the right side? Well, we have to do it since it's a post increment. We have to do it after the arithmetic. But now that we have these new rules, it has to be done before the left side.
So now we get to the left side. var b now contains the value 5. We use that to index into the array. Then do the increment. So at the end of this statement, var b has been incremented twice to 6, and we've assigned the value 7 to the 5th array element.
But the post increment on the right happens before the post increment on the left. Was that clear? Is anybody thinking this is bad code?
Yeah. Well, there's a really good reason you don't want to do this. Because this is no longer undefined behavior, but compilers will warn about it. Now, technically, GCC is correct here, because it said there may be undefined behavior. But Clang just flat out says there's an unsequenced modification in access to var b. You have undefined behavior. Now, this is kind of frightening because this is in C++17 mode. And so the question is the compiler warning you about something that would have undefined behavior, or is the compiler not actually following the new C++17 rules yet?
So we dug a little deeper, and we found some documentation in GCC. See, I'm really good with that. I made the slides happen. So in GCC, this is some of the documentation. Basically what they're saying is, well, we know you're in 17, and if you accidentally or you decide to compile it pre-17, it would be undefined. Personally, I find this confusing because I said I'm in 17. I want to know, is it undefined in 17?
The truth is the modern compilers won't tell you that. And you can take any of the examples off of CPP reference that list, oh, this is the thing that's now defined in 17, and you'll almost always get a warning. So while these new rules exist in C++17, in reality, we can't safely use them.
Undocumented behavior is a little bit different. There's no flat map currently in the C++ standard. But we added a flat map into CopperSpice. And it has the effect of basically the API of STD map, so it's a key value pair. It's designed for very small sets of data. We wanted to add a class, much like you would add a class into your application. But this isn't documented. So the question is, how do we get away with adding classes into our programs when they're not documented in the standard? They already thought about this. It's just undocumented behavior. But it behooves you, when you're designing a class like a QFlat map, make it intelligent, give it a good API, don't introduce undefined behavior, because you're going to have people that are going to be using your classes. So this is the way you extend your applications, something you already knew. But now you know why it's okay for you to add a class, because you're following the rules of extending the language.
The reason we bring this up at this point is because there actually is a statement in the standard. Anything which is not explicitly defined in the standard is undefined behavior. So it sort of sounds like declaring a function or declaring a class is undefined behavior because it's not in the standard. But that's not actually what the standard meant. What they meant is, we are providing a set of tools for you that you can use to define new terms in the language, define classes and methods and functions. When you do so, it's your responsibility to make sure those new entities don't contain any undefined behavior.
So how do you avoid undefined behavior?
Well, as we've shown in some of our earlier slides, you can get compiler warnings on many of these issues. So really, turn on all your warnings and pay attention to them. It's useful to understand at least the high-level shape of the undefined behavior topic so that you know which parts of your program might be a bit dangerous. Try your code on multiple compilers because different compilers will behave differently. You also want to try different optimization options.
And if you're doing a code review and you're having to decide things like our pre and post, change the code. Find a different way to write it. If a code review is too complicated, there's probably something that's incorrect. Ansel and I do pair programming quite a bit. And if you've never done pair programming, I challenge you, find somebody in your office, sit together, maybe have one person, Ansel keeps the standard open, I usually do some of the typing. He likes to surprise me that he's memorized the standard. I kind of know that's not true, but he reads some of the actual syntax for me. But it gives us an instant code review. We don't have to wait 3 or 4 days to find out that we have something bad. If we're sitting there and one of us looks at the code and it's like, that's too complicated. That doesn't make sense. It is very common that I will say, these 10 lines of code look wrong.
And we'll go try the whole process again. So make looking for undefined behavior an explicit part of your code review process. You also need to treat undefined behavior as a critical bug, because it can manifest with any behavior at all. So by definition, it is the highest priority bug you can possibly have, because your entire program is incorrect. There are also static analyzers that can test for certain kinds of undefined behavior, and these are very useful because as programmers, we tend to make certain categories of mistakes more often. And so these tools can help you find them. There's Coverity. The Clang static analyzer is very powerful and open source. And Purify is also available. These are all very valuable tools. But even more importantly are using the sanitizers that are available in modern compilers. Clang has 4 of them. Many of them are available in other compilers as well. And these are tools that actually add checks to your code based on the assumption that you don't have undefined behavior, but maybe we should check at runtime to see if you violated those conditions. And one of the properties of these sanitizers is there are no false positives. So if you turn on address sanitizer and an error is reported, you absolutely have undefined behavior in your program. I mean, it's always possible the sanitizer has a bug, but that tends not to be the case.
There was a time that we thought that the race condition it was reporting, well, how smart is the sanitizer and all the checks? And we were convinced we did not have a race condition. After a couple days, it was quite humbling. We did. We had to change the code. So we suggest that you trust these analyzers and really try to fix what's ever going on.
Some of these are available in GCC, as I mentioned, and I actually heard very recently address sanitizer has become available in the Visual Studio toolchain. There's also a product called Volgren, which is very useful. It's much slower than the sanitizers because it instruments your already built code. But on the other hand, it means you don't have to recompile your program to do this kind of check. So it can be very useful if you have some binary that you can't easily recompile.
We wanted to mention that we have a YouTube channel, and we've done a large number of videos. Somewhere in this list most of these videos are between 10 and 15 minutes. We've done a variety of them. If you're interested in our CopperSpice project, or you just want to go back and study data types, we have a series that's all the way up there in the corner. There's a lot of videos. Please come and watch them. Subscribe to our YouTube channel. Leave us comments, especially if they're nice ones, and ask us questions. We are passionate about helping people understand whether it's CopperSpice or whether it's just C++ in general. And again, these are some of the libraries we've developed. Everything is either LGPL2 or BSD. So if you're not ready to use something like CopperSpice, which is a huge set of libraries, and you just need, a drop-in replacement for STD string that is Unicode aware, CS string is what you can use. So these lower libraries over here, they can just be put into any application. We are C++ 17 at this point. If you want to know what CopperSpice does, Kitchen Sink is a demo that we have. You can build it. We also have pre-built binaries available off of our website. And there are about 30 demos in there that you can play with. Kitchen Sink is not optimized for perfect code. It is optimized to show off the various widgets and the various things that we have in the GUI libraries.
Thank you all for your time. If you have any other questions, we'll open the floor for questions, or if you think of them later, please contact us directly. We're very passionate about making sure that people have the tools they need to write good C++ code.
Thank you.
Barbara, Ansel, thank you very much indeed. Now, if you've got any questions, could you please join us here downstairs, and we will hand you a mic, and then you can ask your question. And in this way, the whole room and people watching online will be able to hear it. Thank you. We've got a volunteer.
Hello, thanks for the presentation.
Thank you.
I wanted to ask about assigning a value to an uninitialized variable. So this is a change of state, but not observable, because you cannot observe a value of an uninitialized variable because it is undefined behavior. So I was wondering why it is a side effect.
Go for it.
That's an excellent question, and I suspect you're referring to this slide.
The slide.
Yeah.
Yes.
Where we're assigning to var b down at the bottom, but var b is uninitialized, so it has no meaningful value. The answer is that there are a lot of parts of the standard that would be very awkward if you had to keep track of variables that had uninitialized values to determine whether you had undefined behavior. So for purposes of specifying the language, it's much better to say assignment to a variable is always a side effect, regardless of its current value or lack of having a value?
For correctness in my own code, I would have initialized var b. So again, we're trying to show examples that show sort of the corner cases. But even if we had put int var b equals 0 on the first line, that would have nothing to do with the number of side effects on the 2 plus 6 on the assignment.
Another way to look at this is if var b were not an int, if it were some data type that had a non-trivial constructor, then var b does already have a value. It was constructed. The construction has already occurred, and now you're assigning a new value. So on the first line, this is actually initialization. It will just construct an object in place. But the second one has to default construct an argument and then call the assignment operator. There's actually a different operation that's occurring. That may be another way to look at it.
Thank you.
Thank you.
Yeah, we've got another one.
Hi.
Hey.
You said the UBs are spread all over the standard. Do you know about any archivist, about any active project where the UBs are actually collected and presented, apart from the apart from the UBSEN and own experience of the programmer?
So you're looking for a collection of everything that comprises UB?
Except for the part when they say what's not defined is undefined.
Fantastic project for you. Can you have it by tomorrow morning?
Sure.
Be fantastic.
To give you
the
a
current
series.
standard is over 1,700 pages. Amazingly, C++ 20, we asked them, it's going to be less pages because they're changing the page formatting. Which is hard for Ansel because he's sort of memorized where certain things are. So now he's got to spend a week relearning the page numbers. That's his job.
But as a direct answer to your
Excellent question.
As a good question, and I don't, neither of us know of any such list. I mean, obviously the true list would be an infinite set because it's anything that's not defined, but I don't even think anybody's gone through and tried to compile a complete list. It would be thousands and thousands of entries.
In the slide that we talked about with the pointer, there was a place where we got the standard, a defect report in. That was part of the problem, is something was over here and something was 3 pages later. And it just didn't occur to us to take those and glue them together. So we talked with people from the standards committee and they're like, I think we could have been more confusing. Let's fix that. And in case anybody runs into this with the standard, please submit a defect report. If something is unclear, let them have an opportunity. Defect reports get in a lot sooner. They don't have to wait until a new version of the standard. They can be summarized elsewhere.
So as another answer to your
Thanks.
question, if there was such a list, it would probably be incorrect.
Yeah, or undefined behavior. Yeah.
As far as confusion goes, example 9, the var A, var B, do thing 1, do thing 1, do thing 2.
Yes.
Why the option 2 is UB and not unspecified behavior?
Excellent question.
Go for it.
The reason why option 2 is UB, well, it depends on an assumption that do thing 2 is actually going to use the pass parameter. And under
It will
option...
use the old value.
What's that?
It will use the old value, and that's probably a logical error.
It's not initialized.
var1 has an uninitialized
Sorry.
value.
Uninitialized. No, it's okay.
Sorry, yeah, that's
we're
UB.
very
Sorry.
sneaky.
Now, in theory, if do thing 2 never uses the pass parameter, it would work, but why would you be passing it then?
Okay, thanks.
Thank you.
Any more questions? I think we've got time for one more, maybe. Yeah?
And if more
If
questions
you've
come
got
up,
more, yeah, just
yes.
do form a queue so that we don't waste time.
Just
Yes.
didn't see the queue anymore. This is kind of related. And also, do you have any feelings about which things are undefined behavior and not? Because standards is not clear on all of the cases. So one of my things that I have problem with is not so much the referencing the null pointer, but there is a new concept of indirection through a null pointer. So would you say that setting up a pointer to a null pointer and then calling a function on it that doesn't touch anything from the class. Is that an undefined behavior or not? This is related because here var1 you said it would be unspecified if you do thing 2 doesn't touch it. So here you have this pointer that's a null pointer and you don't touch it. So it could be a static function, but it isn't declared as such. So would you say it's an undefined behavior or not?
So it sounds like you're specifically talking about calling a method of a class through a null pointer. Yeah, that is absolutely undefined behavior. That does involve a dereference, even if the method never actually explicitly uses anything out of the class.
Okay, could you point me to the place in standard where it says so?
I'll be happy to take that offline.
Virtual.
Yes,
And
because there's actually a
repeat the question.
dereference in the call itself. If you have a pointer
Pointer.
to the object, you have to do, PTR, arrow, method name.
So I couldn't find this in the standard, so that's why I'm asking. But we can take this offline.
Yeah, we'd have to look up the exact area of the spec.
It's only
I've seen it.
1,700 pages. Give him till 3 o'clock.
And I believe the last question, please.
Yes.
Okay, thank you. You mentioned that reading a volatile is also a side effect considered by the standard. Could you explain a bit why is that?
The reason that reading a volatile is a side effect is because it's actually fundamental to the meaning of a volatile variable. Every read of a volatile requires an access to memory. The idea is sort of that volatile represents an address of memory that might be changed somehow externally to your program, that's not in your control. So that read is a side effect because it has observable effects to the system as a whole.
And do keep in mind that list of 4, we did get that from the standard. So that is defined in the standard as this is what a side effect consists of.
It's actually a really awkward part of the standard that deals with volatile, and there's a lot of work underway to redefine it in a better way. The current definition of volatile is known to have a lot of issues, and watch this space because it will
Volatile
continue
is
to evolve.
changing.
Thank you.
Thank you so much.
And coming back to your challenge, you said you were able to solve any kind of problem.
It may be a
any
lot
issue,
of variadic templates and S-Fine.
But from what I gather from what I've heard is that, if you can't, then your ultimate answer is not sure or it depends.
Yes,
which
it
I believe
depends,
is very,
yes.
very clever. We've already had a round of applause, but there were 2 speakers, so let's have another one for Barbara Geller and Alza Semmeltheim.
Thank you.
Thank you.
Thank you very much indeed. Time for a break, and we'll pick up at 10:30, so please do come back at 10:30. Thank you. Thank you very much for coming back. Now, our next talk is going to be fragrant, so maybe you want to use your noses for best experience. And it will be delivered by Jason Turner. And Jason has 2 decades of C++ experience and is a regular conference speaker, developer, and trainer. He is the host of this YouTube channel C++ Weekly and also a co-host of CPP Cast. This is the first ever podcast for C++ developers. And, well, privately, Jason is neither a runner or a dancer, but nevertheless does both regularly. And he's also a big fan of European Christmas markets, so he's looking forward to Wrocław opening one this coming Friday. And, well, let's fasten our seatbelts because, as it turns out, C++ code smells, and proving that will be Jason Turner.
So that introduction where I said, you said I am neither a dancer or a runner, but I do both regularly. Interestingly, I've been doing a lot of training with physicists recently. And just out of curiosity, who here actually, let's see if I can flip this around. And just for the record, I need to see everyone, which is almost impossible with this lighting. So if I retreat to this corner, it's because I'm behind a light and I can actually see you. Who would say that they are a scientist and not a programmer? Are there people here that are? Okay. There's just a couple people in the room. I didn't expect a huge amount. So those of you who just raised your hands, you say you're a scientist, not a programmer. How much of your day do you spend programming? Go ahead. How much of your day do you spend programming? An hour or 2. An hour or 2? Someone in the back, can you yell out, like you said you were a scientist, how much of your day do you spend programming? So you used to be a scientist, but now you code all the time. I think like we just... So you used to code all the time as a physicist as well. Yeah, like we have like this mental picture of ourselves that doesn't necessarily line up with what we do. I run about 16 kilometers a week and I go dancing at least once a week with my wife. But if you were to ask me, I don't think of myself as either of those things. I don't know, just weird. I'm weird. Okay, so yeah, this is things that were already in my introduction. A Microsoft MVP as well, some of the projects that I work on. And I was also thinking about getting a screen like this for my house. Although this would take up most of my house, at least. Well, the room would easily be bigger than my house. Okay, yeah, so I'm independent and available for contracting. That's what I do. Now, I like to say move to the front. That's not going to work here. The front is full. But you have to interrupt me and ask questions. So when I'm expecting questions, I really am going to retreat to my little corner, and there's nothing they can do about it. So that's what we're going to do. Okay. So the name of the talk is C++ best practice. C++ code smells. We're going to start by talking about some best practices. There are 496 C++ core guidelines, 42 items in effective modern C++. Effective modern C++. That doesn't count effective C++, more effective C++, or effective STL. I've got my own C++ best practices guidelines, and there's about 109 items in there. And then there's this book from Andrzej Krzemieński and Herb Sutter called C++ Coding Standards that's got 101 items in it. So from just these 4 resources, we've got 748 best practices. Sounds like a lot. A lot of questions for me. How many of these are unique? Anyone have any idea? I don't, just for the record. How many of them are important that we need to be paying attention to in all the code that we write? Which ones can tools tell us about? So related to this, Herb Sutter in his CBPCon keynote 2018, said we don't have to teach things that all compilers warn on. We need to know what things that the compilers warn on, though. So code smells. According to Wikipedia, a code smell is in computer programming is an innate characteristic in the source code of a program that can possibly indicate a deeper problem. Now, slightly contrary to my introduction, I am not here to convince you that C++ code smells. Okay? I'm here to talk about C++ code smells. Do we get the difference here? We're talking about things in our C++ code that should make us wrinkle our nose up. So I'm asking, the entire point of this talk, when I prepared it, was can I swap around the best practices, and instead of saying there's hundreds of 800 things or whatever to look for, can we reduce this to a set of smells? And does that reduce the set of things that we have to look for in our C++? So I asked Twitter for their favorite C++ code smells, which, by the way, I did get a few people saying, favorite code smells? That's weird. Okay. So what do we think of this code? I'm just going to stand here until someone starts yelling things out. That's how this is going to work. Copy. Uninitialized variable and initialized str, yes? Ooh, we'll get there in just a second. I won't repeat that yet. Wait, what's that? Sorry? Variable is never used after assignment. Okay, I will give you that, but this is what we know as slideware, right? So there's going to be a few things in here that, yeah, it's not practical code, but just for the record, every single one of my examples on these slides should compile. And if you care, you can go to the Godbolt link there, and it should be the exact code as well. Definition, far from first use. Okay, so construction and assignment, that was the crux of what we were, most people were saying. We were defining a variable and then we're assigning it. There's a comment about const. So from Ben Dean here on my Twitter poll, was this construction separate from assignment? So I can declare the variable str and give it a value at the same time. Now, let's see. We can interact with all of my slides too if we want to. So we're not going to dig into assembly today. I'm not planning to. I mean, you can if you want to, or you can ask me questions. But just for the record, if I run this, or if I compile this program, I've got a fair bit of code generated. The compiler has to deal with the fact that I asked for a default constructed string and then I assigned to it. If I do the value and assignment and declaration on the same line, the compiler is able to completely see through this. And it's able to optimize the entire result away. So at the moment, we're just saying more assembly bad, less assembly good. That's not always true, though. Okay, from Ben. What about this? I heard an ooh, an ew. Did you smell something? What? Sorry. Output arguments. Okay. Out variables from Ollie here. So we swap this around. I have something that is passing in a reference, and then I am probably assigning it somewhere, versus this one, I'm returning a string. One. So I'm getting interaction from the front row. Now this is the problem for those of you who chose to sit in the back row. Way back there. Okay. So the answer I got from the front row was 1. 1 parameter. Does anyone see that parameter? Yeah, go ahead, yell. Space for the result. So the compiler, yes, when we call a function, we have to say, hey, where is this return value going to end up living? That's something that has to be done. So ultimately, we could argue that this actually takes one parameter, and it is where the return value would go. And if we... I wasn't planning to go into this bunch of assembly right now, but I guess I am. It's where we are. Okay. So I am actually setting up stack space, and I am storing that stack space in RDI. RDI is the first parameter on the 64-bit calling conventions for Intel, and then I am calling my function. So I have set something up for the first parameter to this function, and that is the stack space where the return string is going to live. All right. So out variables. Also, Sean Parent has a very well-written article up here called Stop Using Out Arguments that you can check out if you would like. What do we think of this code? Let's see, I've got some process data. I'm checking for something. If something is true, I'm calling another function called process more. Now I'm wondering if I should wander up and down the aisles because that sounds like fun. Why not? What? Find if. You know what? I already apologize in advance to anyone on YouTube and the people manning the cameras if I do actually end up going up and down the stairs. We'll see what happens. So why not find if? Okay. Or maybe put another way. Any of. Okay. Yes. So algorithms is what we're talking about here. And the general overarching principle here is raw loops. You're both saying that we can use algorithms here. Algorithms are a handy way to avoid raw loops. So I can do, let's see, I chose all of here. And I'm saying if all of the values are in this range, then I'm setting this value, and then I'm doing my if statement. So, raw loops, Sean Parent, he did not respond on Twitter, but you know, well, Sean gets known for this. Who all has seen Sean's C++ seasoning talk? Okay, so those of you who haven't watched it, you can go watch it. That's on your homework assignment. More code for you to look at while I get a drink of water. What? You have to yell louder. More algorithms, repetitive code. That's what we've got. Okay. Anything else? Oh, pipes in the hose. Pipes in the hose, right here. Yeah. That's what happens when you copy and paste code, right? Who all's made a mistake like this before? If you're not raising your hand, you haven't been programming for very long. Okay, so we've got, we've got this, hose in the pipes. This is a more general concept of multi-step functions. What I really wanted to call out was code like this, step 1, step 2, step 3, step 4. But if we can depose our code into functions or lambdas, I don't really care if you use a function or a lambda here, honestly. I mean, a lambda is a function, but I mean a free function that's been named. Now, just out of curiosity, who prefers this version? I'm pretty sure I just heard someone yell, old people. Scientist, okay. I'm sorry, did you just imply that old people are scientists or scientists are old people? Oh, okay. People who like fixing code. Okay. So everyone in the room is okay with this version? All right. All right. I'm okay with this version, but I often get people who think that it starts to get a little bit too much when you've got multiple lambdas and such defined. I ask, are comments necessary in this code? Comments. Comments. Are they? No? Now, I don't have a slide that says this, but let's go ahead and indulge ourselves for a minute. Are comments a code smell? No, yes, and it depends are the answers that I just got. If it says what the code is, they are, is the one person I've got right in the middle of the room, just for the record. That's actually, I think you're almost, you go to the theater often, don't you? Okay, so it's an interesting question to stop and think about. If you've got a bunch of comments over your code that's explaining what's happening, then perhaps you just need to name things better and maybe create functions and such. Functions are handy. They've been around for 70 years or something. All right, multi-step functions. Bjorn, Tony Van Eerd, Peter. I think Bjorn's the only person who might be in the room. Bjorn, are you in the room? I have no idea. Okay, too bright. What do we think here? Operator or order? Oh no, we don't have any problem with order of operations, if that's what you're saying. Const on the right-hand side and the left-hand side. Oh. All right. Just want to make sure that we're clear. So you said const on the left-hand side and on the right-hand side? So you're saying right here. Okay, all right, just wanted to be, oh, wait, do I want, sorry, const and data const, oh, yes, so that's what I was wondering. You want me to put it here? Oh, wait, I'm sorry, what? No? Wait, here? Not here. Okay, they do mean the same thing, yes, and we can spend an entire hour arguing about which side the const should be on, but we're not going to do that. Yes, we are. Barbara will be joining me on stage to argue about the... I don't care what side you put the const on, I really don't. I do think, though, as C++ programmers, we have to be used to reading it on both sides, right? Depending, you might change jobs, even if everyone you work with right now agrees on one or the other. Okay, so we are missing const on both sides of this. Yeah, a lot of the code examples that I put up, by the way, are things that I have either personally done or are things that I have seen in real code. I don't just make up most of these things. I make up some of them, not most of them. Okay, so const and const. This is non-canonical operators is my code smell here. By the way, that was just me. I didn't get that one on Twitter. Going back to this code, by the way, we corrected it. We've got hose times hose, not pipes times hose. What else do we see? No. Well, you said ranged fours, right? Precision loss. I am summing up implicit cast to int. That's what I'm going for, but where? On the plus assignment. Okay, you're saying so on lines 7 and 12. And so we're making an assumption because we're multiplying by the impy compiler, or the standard defined value for pi, that we are intending to do floating point operations here, and we're assigning them to integers. So that's probably bad. Anything else? And the return is a double, and I'm returning an int into a double. Yeah, so clearly I'm not doing what I intended to do here. Size is unsigned. Okay, what's that? Hopefully, we don't know what the type is. It's probably unsigned. We're probably operating on a standard container here. If we're operating on a standard container, what is the return type of size? Size t, which is on our... Who does 64-bit programming daily? Or maybe I should do this the other way around. Who does 32-bit programming? Oh, that's interesting. It's like half and half for people who chose to raise their hands. Huh. Okay, let's talk about our 64-bit platform. What is size t? 64-bit, unsigned. What is int? It depends. What did you say? It's signed. It's definitely signed. 32-bit signed. That's what you said? Okay. Yeah. Not smaller than short, not bigger than long, but they can't all be the same size. Really? Sorry, he said at least 20 bits. What we know in practical use is that int is assigned 32-bit integer on every platform that anyone is using today. I'm not aware of any platform where that's not true. I guess maybe unless AVR is signed 16-bit integer. And size t is going to be an unsigned 64-bit integer. So we're doing lots of conversions in this code. Okay, we'll move on from that. What do we think of this code? Can't see a thing from that corner. Implicit construction of a string, says the voice in the front. Yes. Where's that implicit construction of a string occur? Line 10. Yes. Okay. So, I already had a string. Yes. Who has done this? Yeah. Yes. The person giving all the answers, Ansel down here, is like, yes, I've done it. Yeah. I've make a bold statement here that says this always exists in code that has existed for a long time. You can go look for it in your own code later. All right. What is move? A cast to what? Cast to an R-value reference. It is an unconditional cast, more explicitly, to an R-value reference of the given type. So this is just an unconditional cast to an R-string R-value reference. Redundant. Preventing RVO. Yeah. What's that? Okay, so you say it's a pessimistic move. Yes, so we get warnings from our compilers now on this. I just wanted to go ahead and click on it. Moving a local object in a return statement prevents copy elision. So we have just explicitly chosen to make our code less efficient just for the fun of it. This is the return by move anti-pattern here. And I realize I am going slowly, so I am going to speed up a little bit. Okay, so standard move is another type of conversion that is a code smell. So just like implicit conversions with our C string to string, we've got standard move as a code smell. Now, this was just in the last talk on undefined behavior is not an error. What value is returned from main? Nasal demons. That's, I think, the... Your hard drive is formatted. Probably not those hard drive formatted here. I would just say, just for the record, on every compiler that I've ever played with, it does return the same value, but it is undefined behavior. So it's not good code. Anyone want to take a guess as to what the compiler is going to return? 4, yeah. It's great fun, actually. And also, just for the record, no compiler warns on this. I can't help myself. I love that all the compilers do the same thing here. They set up, I just turned off optimizations, they set up the stack space, they move 4 into that memory location, then they move 13 into that memory location, and then return 4. It's a constant. It can't change. All right, so modifying a const object during its lifetime is undefined behavior. Const cast is another explicit conversion that is a code smell. All right. Weak typing. Which int is which? This came from Arna. Arna first mentioned it, and then Matt clarified here the which int is which interface. This is great. If you just take a minute and stare at the socket API, when we've got, is it the domain, is it the type, or is it the protocol? It's terrible. Weak interfaces. But we don't have much choice in C. But fortunately, we are programming in C++. So code with conversions, implicit and explicit and cast. This came from many different people. Can our compilers warn us on this code that we were just discussing? We might get narrowing warnings. Now, interestingly, I just noticed this when I was reviewing my slides. This version goes back to the host times pipes. I think, actually, I could be wrong. I think PVS Studio would warn on this. Is there anyone here who uses PVS Studio? I come like one person raising your hands. Would it warn on this? Do you know? On the host times pipes part? Yes? I think it would. I'm pretty sure it would. Because it does analysis of for loops that are beside each other, and if they look similar but wrong. Oh, right, we can't compile this one, unfortunately, because I'm working on this data object that doesn't exist yet. But if we've got our narrowing conversions on, W conversion, then we can get some warnings here. We did already see that we can get warnings from this one. I jumped ahead a little bit when I compiled it, and we saw that we get our pessimizing moved style warning. So, code with warnings. Bjorn and Dimitar Mirchev mentioned this, and on the Twitter thread. What warning levels do we use? Who uses GCC and who uses GCC? So that's like most of you. Is W all mean all the warnings are enabled? Okay, good. No is the answer for the sake of the recording. All right. What are the implications of a static variable? What happens when I execute this function? What happens on line 8? What's that? Static initialization may occur. Nothing happens. Okay, so, you know, sometimes I just can't help myself. We're going to end up having to skip something at the end of this, but it's fine. It's all good. You have to have a lock and an unlock to check to see if the variable is initialized. When I call do things, I blah, 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 setup stack, whatever. This is with all optimizations is enabled. On line 6 in the disassembly, I have to load a guard variable. That guard variable indicates whether or not my standard string has been initialized yet. The first time this function is called, it's going to get a guard lock. It's going to check the guard variable. If I scroll down, it then, if it says that it has not yet been initialized, it'll acquire a lock, it will initialize the string, and then it'll free the lock. So every single time we execute this function, it has to do this check of this guard variable. There has to be a switch here when this line executes. With a trivial type, the compiler may elide these checks. With a standard string, that's not going to today. Maybe with C++20 and constexpr constructors for strings, it's maybe hypothetically possible, but this is the world that we're in. We can see that it has to do these guard variable checks and locks on this code. All right, each time the variable's accessed, we do that. What do we think of this version, though? You said static is redundant. Unfortunately, it's actually not. Static constexpr variables are not static. Depending on this type, it is entirely possible and allowed that the compiler would still initialize this variable locally every time that the function is entered if we don't have static here. Static constexpr is more logically correct as well because this is a value that is true for the entire lifetime of the program. But it does go counter to what we expect. We think, oh, because it's constexpr, it will do this at compile time. Constexpr means that the result of the value must be available at compile time. And if we were using it in a compile time context after this, then yes, it would be required to do it at compile time. But in this particular code, certainly the static is not redundant. So, static const is a code smell that should be constexpr, or constexpr static. Static const. This is code that I found in a real library recently. I mean, with names changed to protect the innocent kind of thing. Well, I have what do you think up there, so I'm just watching you all read the slide right now. All right, so I've got an extern int const, and then in my CPP file, I'm giving it a value. If I flip this code around like this, because when I compile value.cpp, this is what the compiler sees. What happens when I go to access that value on line 4? Depends on what? Return the linked value. And it has to go and find this value somewhere. It has to look up some memory location. Unless we're doing link time optimization, it doesn't know the value of this. It's kind of like I've just said to the compiler, I have some really important information for you, but I'm not going to tell you. Extern const is also a code smell. Now, I would say there are places where it might be reasonable to do this if you're linking in different object files that give you different values or something because you have a very complicated build process, but I still wouldn't say it's great code. Better option, constexpr. We pretty much guarantee if I say what's the better option, the answer is constexpr. So, what do we think of this code? What's that? No exception safety. I still didn't catch what you said right here, sorry. You're saying I should use unique pointer. Don't use naked deletes. Ooh, that's interesting. I've never heard it flipped around that way before. Never put anything on the heap that we don't have to. Okay, we'll get there in just a second. So, of course, this is wasteful and the heap should be avoided if possible. but make unique is a better option here. So we're doing a raw new, we're doing a raw delete, we're doing manual memory management. As of C++ 14 at least, there's absolutely no reason to ever do raw memory management. Well, that's strong words. It's very, very rare that there's a legitimate reason to do raw memory management. Okay, raw, new, and delete. Next code smell. So this is the code smells that we have come to at this point. Construction is separate from assignment. Output variables, raw loops, multi-step functions, non-canonical operators, code with conversions, casting away const, code with warnings, static const, extern const. Then we're getting to a part of the screen that you can't see, but my slides almost never go to the bottom. Raw, new, and delete. Okay. But, well, okay, come back around to that just a second. Let's do a quick code review here. We have time for this. Yes, we definitely have time for this. Tell me how I'm going to change this code. Okay. Oh, right. You said only have 2 strings. Oh, why have? All right, sorry. I have to take a step back and explain where this code sample came from. I got this really awesome magazine when I was in the UK this year, beginning of the year. That was C++ and Python for beginners. Oh, I probably shouldn't have said the title of the magazine. Anyhow, this is one of the examples from that magazine. So this is a learning C++ example. So yes, we have a bunch of code that's doing unnecessary things, but let's say that it's necessary for the sake of the teaching example to talk about variables and how we can concatenate strings together in C++ and what functions are available in the strings. So that part we don't want to get rid of, but we want to just say, okay, if we're keeping this teaching example, all right, what should we do? Okay, let's start with string should be const. Ooh, string view. So I'm making my strings const. Satisfy everyone. Okay, so inconsistent const declarations, yes. Okay, move length to line 11. Oops. Wait. So, yeah, here's size t being said, but let's, okay, so. Okay, so I've got, you're saying auto const. Const auto const. Okay, I've heard a few different things. Let's just go, I'm going to put the auto here. So const string, someone said const string view. I think our example starts to fall apart, yeah. So we can't do the concatenation if we're using string views, although I'm on board with the concept. Anything else? Well, we're not doing anything with the value. We'll get an implicit conversion loss probably here, but we can do that. All right, anything else? Auto on line 8, okay. I'm sorry, this is bugging me. I'm going to have to do this. You're saying, so the comment was it's better to append the string instead of doing the plus operator because that introduces the unnecessary temporary. We won't take the time to argue about that at the moment, but I would think it's probably a similar amount of work because it's going to have to allocate a new buffer and copy all of the bytes into the new buffer versus allocating a new buffer and copying all the bytes into the new buffer. It's probably a similar amount of work. In 17, it will be move-alighted. Which one? Yeah, it's always move-alighted. You're talking about the one returned from the plus operator? In 17, it is guaranteed to be move-alighted. We can't actually say that because we don't know about the implementation of the plus operator. It's only guaranteed to be move-alighted if it is a non-named return value from the implementation of the plus operator. So we can't reason about that at the moment. Okay, anything else? Return directly to without length. Yeah, we could do that. I don't know, there's still one other thing that's like really bothering me though, that's not just like a... What's that? Yeah, explicit, you're saying using namespace is bothering you. Is that what you're saying? All right. Okay. Or put it inside the function. That's fine. Okay, so that's where we're going to leave this example at the moment. There were several other comments from people, for those of you who maybe in the back of the room didn't hear this, that I could have avoided giving length a name. I could have just recalled .size, or I could have just called .size on the return value of greet1 plus greet2 or something like that. But I think this is getting okay for a teaching example here, for what kinds of things we can do with a string. Okay. One thing that keeps coming up, and we've only kind of mentioned it, what was it? Over and over again it came up. Use const. Okay. We'll break it down. This one versus this one? Const. Return value versus out parameter? Const, line 4, or on the bottom. Explicit loop, raw loop versus algorithm. Shows up again. Const, right here. So, as we all just said, what kept coming up was const. This is not the first time that const has been mentioned at a conference, just for the record. This is Kate Gregory. James McNellis gave a talk together. I also have a clip from myself after this.
Marking everything const that you possibly can. Not like, oh, I have to, and then getting away with whatever you don't have to, but turning it around and saying, mark it const unless I absolutely can't. Because then, remember, the compiler is your friend. And so anywhere that you have any kind of errors of thought, they'll be caught for you.
Does anyone have any ideas for how we might be able to get this to use less overhead? Did I hear const expr? Can anyone think of a simpler way?
I'm sorry, but I just have to pause myself at this point. Because at this particular moment at CPPCon 2016, I thought, at that moment, I thought, const expr is kind of complicated. It doesn't necessarily get us what we want all the time. Now, for those of you who've seen some of my later talks, that might strike you as odd. Because since then, I've given talks called const expr all the things, for example. So I just had to pause myself for a moment there because, yeah, I at the time thought, const expr is too complicated. But we can see the disassembly on the right-hand side, and in a moment we'll get there.
To get this to have less overhead. What's that? Pre-computed table. Yeah, that could work, but const expr would kind of get us there, I think, anyhow. So, is there some best practice about using const anywhere possible? Has anyone ever heard that? So what happens if we make our static array here of color data const?
So what I've had 3 years to reflect on this talk. What I've learned since then is by making my static array const, the compiler said this is const, it can't change. It moved the data from the stack to the constant data section of the binary, and then once it had that information, it chose to do more constant folding after that and optimize the rest of the code away. Can have real impact. It's unlikely that you will encounter code like this where adding const makes your entire program go away, but it is possible. So, with const, any lack of const is a code smell. That's what I will say. Const forces us into more organized code, it prevents common errors, and it encourages more use of our algorithms. But then we have to review when and where and why and how to use const. Should I const my value parameter? I'm talking about count here. Should I const count? You can't, you should, and it depends. I believe were the 3 that I heard. Do you like bugs in your code? Does anyone see the bug in this code? Yeah. So I've got ++ count, and I should have ++I. Minus. Why? Minus, out. Oh, yeah, okay. So let's see. If I is less than count. Except if count were 0. Oh, no, then it still wouldn't enter the loop. Yeah, you're right. Minus count. That would solve the bug. Okay. Use what? Negative count? It's, yeah. So just for the record, I actually wrote this bug live in front of a class of students. I'm like, let's just make a quick for loop here, and I did this. But when I was writing it, I made count const because that is my reflex, is to make everything const, and the example didn't compile. So I was like, yes, best example ever. Okay, if I make it const, then it fails to compile. In a good way. Should string s be const? No, why not? Because I'm doing it to move, and then it's going to become a copy. So if we want to actually do a move here, then yeah, we can't move a const object. That should be not const. Do I const temporary values, like on line 7? If line 8 exists, then I shouldn't, was the comment down here. So again, we're breaking our move operation. This becomes a copy again. Silently reverts to a copy. Okay, I'll just tell you, I have a little bit of circular logic here, and I love it. It's my favorite circular logic for myself that I've made. So I can't move a const object. So I made it not const. However, I just broke my main rule of making everything const. What's my out? Don't use the name temporary, which is effectively what you were saying, right? Oh, sorry. No. Okay, so his comment was, you put the const first, and if it doesn't compile with the const, then you remove the const and you live without the const. So in some cases, the usage might require that you don't have const. It's rare. It's usually, and then I've got a comment in the middle that said, don't use the named temporary here. So I can't move a const. That's not const. I don't like that. If I can just go to this version. Okay? So in this version, I am going to be doing a construct and then a move operation. In this version, I'm doing a construct and then a copy operation. And in this version, I am directly constructing the string parameter in place. There is no copy or move to even reason about at all. Or write a function. Those are handy. We mentioned them earlier. So if I can give this thing a reasonable name, then I can take the thing that constructs the string and pass it to the thing that consumes the string. Do I const returned objects? Now, we already just discussed not naming a thing, but is this code okay? No? Yes. What's that? It requires a copy. Who says, I'm going to get where I can see you again. Who says that this value requires a copy? Okay, who says it's a move? Who says it's neither? Okay, we got more hands with the neither, so we'll go with that as the correct answer. Yeah, no, this is okay. This is okay. This is going to come into return value optimization, and every compiler that I have tested after 1997. Yes, every compiler after 1997 that I've played with, this would be return value optimization. Now what are we doing? What happens on line 5? It's not a trick question. We construct a string. Line 6. We construct a string. Okay, and then on line 9, what's it going to do? Line 9 or 11? It's going to use one or the other, but what? The compiler can't elide the return, the copy or the move. It's not going to be return value optimization. Depends on our compiler technically here. If we're C++, pre-C++ 11, what do we get? Does anyone know? A copy. If it's 11 or later, it's a move. And so what happens if we move a const string? We get a copy. So named return value optimization can apply. After C++ 11, it's equivalent to as if we have done this. So like we just said, this is unfortunately accidentally a copy. This is definitely not what we wanted our code to do. So we actually managed to break our return value optimization. We want to call it that, but it's not really return value optimization. It's just harder for us to think about it. But the compiler has to create the first string, it has to create the second string, and then has to decide what to do with the return value. So, how do we resolve this problem? Lambda ternary. And I'm sorry, if ternary is the right answer, you need to rephrase the question. Ternary is sometimes the right answer. Okay. All right, lambda, someone said. Another option. Any other options? If we move the value to the return statement, we're gonna take an intermediate step first. This code does have return value optimization. It doesn't have to do the construction of both strings. It's going to execute the correct code path and then do the return. So this can actually do return value optimization. Or we can do something like this, and we don't have to give the thing a name. Avoiding the temporary so we don't have to worry about whether or not what the result is gives us the optimal solution here. I just tested this code, and it's in an episode of C++ Weekly that's going to go live. It's episode 197, so it's going to go live 2 weeks before Christmas. With the Borland C++ compiler for OS2 from 1994, because I needed to know. That compiler from 1994 cannot do return value optimization with this code. It's going to do a copy on return. With this code and our compiler from 1994, we get the optimal solution always. This best practice has not changed in at least 25 years. I was recently compiling LLVM while preparing for this talk, and I got warnings all over the place on this code that looked just like this inside of LLVM, compiling it with Clang. Line 5, this is a warning because it is an unnecessary move. The local return value is going to be moved implicitly anyhow. Even though, so with unique pointer here, we might have thought, oh, well, you know, maybe I need move here, but no, you don't. That's a warning. Redundant move and return statement. So do we const value return types? It's not meaningless. I got meaningless from several people. I'll explain. So first of all, this code is weird. I can take the return value from a function and I can mutate it. So apparently, in some books a long time ago, this was said, we need to forbid weird behavior like this by making this const. And now this code fails to compile. So if anyone, does anyone working on a code base that says that you should make that return value const? All right, not in this room. Okay. This is not allowed with built-in types. This const is necessary to make our built-in, our defined user-defined type behave more like a built-in type. We can do our value qualified member functions instead, but no one does that. But we have this problem. On line 9, we are constructing an object. On line 10, we are implicitly doing move assignment because the thing coming out of this function is an R value. We're going to get an implicit move assignment here. What happens if I make this const? Can't move from a const object. We just broke our assignment here. This becomes copy assignment. All of our compilers will warn on this, by the way. So we don't want to const value return types. It breaks move operations. Of course, we could have rewritten this code so that this issue doesn't come up. We can, this is still not a good idea, but of course here, if we just capture the return value into a named object, it's neither a copy nor a move. We don't have to reason about those things. Const and auto. So 3 main smells, and I am rapidly running out of time, so I'm going to go much faster. Missing and ignored compiler warnings. Special checks exist for these things. CVP check can help you reduce variable scope. Variable can be const is a warning from various tools. The C++ core guidelines include raw memory use checkers. We've got pessimizing move warnings. We've got const return values in Clang tidy. So first one, missing and ignored compiler warnings. Second one, missing const and const expert and misplace const. Either const isn't where it should be or it is where it shouldn't be. And using const forces us into, or using const expert when we can, forces us into more efficient containers like standard array, using our algorithms and using numerics. This is a quote from me, east const or west const, I don't care. Use const. I'm also down at the bottom here, which is getting a little bit blurred out. I am not an almost always auto fan, but it does push us in the right direction because we have to initialize auto variables. And weak types in cast. Unfortunately, the C++ standard library doesn't help us here. String, path, const char star, string view, so many implicit conversions. Optional variant, shared pointer, have non-explicit constructors that contribute to these things. So we need to use stronger typing, see items 1 and 2, so that the compiler helps us catch these things. For the rest, we just have to read the code, use auto, and use the correct types to avoid casting. And we can avoid named temporaries to avoid using move. Of course, there's many other things. Most of the things that I found can be distilled down into these 3. So Sometimes the correct answer to why isn't that const is because it's not the right time to use const, but we do want to ask ourselves the question, why isn't that value const? We don't have time for the bonus code review. That will be in the slides later. So that's who I am. We've got 30 seconds left, so if anyone, we don't have time for questions. Thank you, everyone.
Thank you.
Oh, well, it's up to you. We've got 20 seconds.
Just a quick question or two, if you're interested. Now or never. So please join us here downstairs. 1 or 2 people, and we just have...
No, they're all ready for lunch or something. Oh, there we go.
I wanted to ask about move. You said, and other people say it's unconditional cast.
Yes.
But in the examples, we see that it sometimes actually allows move, sometimes it doesn't. So isn't calling it unconditional cast to an R value actually misleading?
No, it is actually an unconditional cast to an R value. But if you have a const value, it's still going to do an unconditional cast to an R value, but it now becomes a const R value reference. So if it's a const R value reference, then, I mean, because it did that. It did an unconditional cast to an R value reference. If it has a const R value reference, a const R value reference will not match the move constructor, so it can't, or the move assignment, so it can't do a move operation on it. Instead, it's going to decay to calling the copy constructor a copy assignment. It is still an unconditional cast to an R value reference, it just may or may not be const, and then things fall down.
Okay, thanks.
Mm-hmm.
So at the start of the speech, you said we have about 800 best practices.
Yeah.
And the thing I take out of your speech is that it's actually only one, and it's to use const.
That is what I tried to get to, yes. Yeah.
And all the other things basically come indirectly when I reuse const.
I would agree, except for some of these things like implicit conversions. Const doesn't catch those. I honestly, truly, when I started preparing this talk, my goal was to say that there's exactly one best practice, and it is to use const. But I realized I have to add the turn on all your compiler warnings to catch the rest of the things that const can't.
All right. Thank you very much.
Thank you. Thank you again.
There doesn't seem to be any more questions, so Jason Turner.
Thanks. Whew, it is hot up here.
Right, thanks very much. Half-hour break, and then at 12 exactly we'll continue. Thank you. So do show up back in this room at 12, please. Welcome back. Let's continue with our program as advertised. But before we do that, just two little announcements. Announcement number one is if you could please not use these doors over here, either to leave the room or to enter the room. This is because of the fire regulations and we treat them seriously. So if we leave or walk in through the main door, we are counted so that the cinema crew knows how many of us there are in this room. So please, if you could refrain yourself from using these doors to either leave the room or walk in the room. And also announcement number two, please do remember that you can comment or rank the talks on the Code Dive website. It's already live, so you can leave your remarks there. And now let's move on to our next speaker. And our next speaker is a very interesting person because he's a Code Dive veteran. And Andrzej Krzemieński has never missed a Code Dive even once, so it's going to be his 6th time. And that in itself, I think, deserves a big round of applause. Thank you. Andrzej has been a software developer since 2004. He works mostly with C++ in commercial software, which includes safety-related and high-performance systems. He's a member of the C++ Standards Committee and a Boost developer, and he's also a co-organizer of the C++ user group in Kraków in Poland, and he's known to the community for his blog on C++. Now, the title of his talk, it sounds really impressive, and it's incredibly difficult to pronounce, but let me try. Preconditions, postconditions, invariants, how they help write robust programs. Let's put our hands together for Andrzej Krzemieński.
Thank you. Okay, so hi everyone. I can see you can hear me. Thank you for attending this talk. It will be about, those difficult words, preconditions, invariants, less so about postconditions. And first, they're already there. Consciously or not, we are using them. So the choice here is to be aware of this, of their existence or not. Second, we'll see how they are used by different people today. And last, we'll see what a language can do to help handle them. And before any definitions, we will go through some motivating examples. This is functions that you will often find. It checks whether one of the offers or which of the offers is better, and it gets us the result. And because we see this pointer dereference, sooner or later we have to ask this question: what if one of those pointers happens to be null? And that's it. So for now, we are just asking these questions. So here's a second example. We have a function that gets some integer and a range represented by lower and upper bound, and it returns us the answer if this x is in range or not. And there is no pointer dereference here, so it looks like everything is fine. But what if this low is greater than high? What if? And another example. We get a C-style string, and we need to compute its length. So, of course, we need to ask, what if we are given a null pointer, but also, what if it's not null and there is some characters underneath, but if we iterate over it, there is no 0 to be found anywhere? What then? So those are the questions. Let us contemplate about them for a while. And let me show you yet another one. This function looks really simple. It just takes an integer and just gives us the answer whether it's even or odd. It looks almost impossible that anything could go wrong with it. But can you see the catch here? Negative numbers. No, it works for negative numbers. -1 is all ones, so it will still say 1 is odd, -2 is even. It will work. I checked it. There is no catch here. It just works. And more important thing is, those functions really exist and are really neat because we don't have to answer all those questions. And we call them white contract functions, which means any input value is fine. Whatever you give me, I know how to answer how to give you the answer. And in contrast to that, those functions that we've seen before, like length, we call them narrow contract functions, which means some inputs are, the compiler will eat them like null pointers, but we consider the authors of the functions or the callers of the functions, we consider them invalid. And going back to one of the initial examples, we can see the declaration like this. And there are two parts of the types of the input parameters. We have this offer, which represent the concept, not like C++20 concepts, but the abstract concept that we talk in normal life. We talk about the offers. I can offer you something. You can offer me something back. So it's the part that represents some real abstraction that we want to talk about. And the pointer here is something that doesn't really talk about the abstractions. I needed to use it for some technical reasons because I chose this language. This language uses pointers. There were technical reasons, but they have nothing to do with business logic. And this basically can be told about every type in C++. It consists of two parts. On the one hand, it represents abstractions or concepts that we want to talk about. And on the other, there is some engineering ballast, let's call it like this, something that we have to live with because we are programming in a language. And we can say the same about the entire programs. On the one hand, they represent business logic, and on the other hand, they represent some language-specific ballast that we need to live with because we chose this language. I could have declared my function like this, just taking those offers by value, and I wouldn't have to answer those questions about null pointers. But even the offer alone carries some language-specific ballast. Like the offer may not be copyable, so my function will not even compile in some context. Or maybe it compiles, but if I need to do the copies, it will take so long that the program may be correct, but no one will use it because it's too slow. So even the simple thing as being able to be copied and passing by value carries some language-specific ballast that is not related to our real-life abstractions, because offers in real life are not copyable or not copyable. I could have used a reference and passed these arguments by reference, and this is usually a good thing to do, if we can. But references have their own ballast. We'll not dig into this, but they have their own problems. They don't represent constants. They can change over time. The objects underneath constant references can change, even if we often don't think about them this way. But another reason may be that there is some other engineering ballast in the outer context. Like maybe I'm storing these offers in a vector. I cannot store them by value because they are not copyable or too expensive to copy. I cannot store references because vectors cannot store references, so it needs to be a pointer, and I need to sort them. So I will have to use pointers and live with the situation that from the type system perspective, some values are accepted, but they mean nothing in our business model. Like null pointer offer is not an offer. So it cannot be better or worse than any other offer. And the contract expressions like preconditions, what they do is to help us define and talk about these gaps between the business logic and between the type system. And the failure to recognize the difference between the two causes many bugs. So business logic is an offer, in our case, from a real life, and from the type system perspective is pointer to a const object of class offer, and they are different. And usually what we will see in the code is, in the declarations of our function, is a comment, because we have no better means of communicating this difference between the type system and what we are really talking about. So we'll have to put it in the comments in order to communicate to our callers. Because there is a potential risk here, because we see the problem inside the function, and we may be led to thinking that we have to do something about it inside the function. But it's actually the caller's problem to understand this difference and to make use of it. So we have to communicate it either in documentation or in the comments so that he or she, the caller, doesn't make those mistakes. And the semantics at the high level is, if you don't respect this constraint that we have put here, our function is meaningless. It may do something, may return something, but it isn't an offer or a better offer. Now it's just a low-level computation on pointers and nothing more. So let's get back to the first question. What happens if one of those pointers is null? Because if we execute the program, something will happen. And the C++ gives us the answer. It is undefined behavior, or UB for short. I will be using UB because it's so commonly used term that it has to have an abbreviation. But this is at language level. What will happen when the code is executed? We don't know what, but most likely it will be one of those two situations. On some platforms, 0 can be treated as an address as any other. So we can go there, maybe it exists, and maybe it has some values, and maybe we can, it's using income, so maybe we can extract some income. There will be some value. It was never meant to be interpreted as income, but maybe it will be there. And we can compare it against other incomes and return value. And if we are a financial server that needs to do serious decisions about trading, and companies' business depends on it, we will be doing these decisions based on random numbers. You can get into serious financial problems, but also into legal problems, because you are doing operations on random numbers. But the other thing that can happen, and this is more likely, is that the program will stop immediately. It will crash. And one thing is important to note here. It will crash because someone put a lot of effort to implement this feature of crashing the program early as soon as something bad is detected. This is done to, the system will do it to protect itself, the system, from your application, to protect other applications from your application if you are accessing memory at random points. And it will also do it to protect yourself and your program from itself in order for it not to do random operations anymore. So it is a very useful feature, and someone had to implement it. But there is one other thing that can happen with UB. It can help detect bugs in your program, and I mean statically, not without even running the program, just by observing the flows in the program, the abstract syntax tree, and checking if there is a situation that will lead to undefined behavior. So let's see how it works. And we heard it this morning, that all the tools, the compilers, code reviewers even, should assume that it is never the programmer's intention to cause undefined behavior. So if we are able to find one in our program, it means there is a bug somewhere. Like, let's imagine that our function is inline, so that the static analyzer can look inside the body of the function. to see what's going on, that there are pointers being the reference. And then later on, if there is a call like this that passes a null pointer here, static analyzer can detect that there is a control flow that leads to a null pointer being the reference. And it gives us a warning. It doesn't know what happens. It doesn't understand the logic of our code, but it knows one thing. You never wanted that. So the programmer should go back now and see what is wrong. And of course, no one will be passing null pointers like this. The control flow will be something complicated. There's ifs, there are some exceptions thrown, caught at random places. You may think you covered every path, but the static analyzer can see better, and it can warn you. One good thing about our constraints like this is that usually we can express them as C++ expressions and or C++ functions, like here. It is a valid code. If we put it inside the function body, it would compile. And we can make use of it. As we said, it's a caller's responsibility to understand how we interpret these values and to make sure that bad values are not passed. But if they are passed nonetheless, we can do something to prevent damage and alert the caller that they are doing something wrong. So we can execute the condition as the first thing when we enter to the function and then respond to this. But the thing is that to execute the predicate is easy, but to respond is hard and actually impossible to do in a satisfactory way, because the place of the bugs is the proper way of handling the bugs is to not have them in the code. Once you have them and detected at runtime, you cannot fix it. You can just mitigate the consequences. So we can just apply some safe default, like return false. We cannot say for sure that this offer is better than this one, so we say it isn't. Just some default. And it may look clever, but it has some problems. First, we have artificially widened the contract. It used to be a narrow contract. Now it's wide, but the other values that we allow, null pointers, make that we are no longer talking about the offers. Now we are talking about the pointers. And this function is just doing some, or we say this function is just doing some operations on the pointers. Maybe you can interpret it as offers, maybe not. We have lowered the abstraction. And the second, it looks like a predicate, but it doesn't fulfill the mathematical properties of a predicate. Like we would expect that if the first equation here holds and the second holds, we would expect and assume that the third one will also hold, but it doesn't, actually, because we didn't pay attention to stick to the mathematical properties of a predicate. Which means that the algorithm, if we use sort, for example, will make this assumption, and if it sorts with this predicate, it is likely that it will never terminate. These assumptions will, because it's making these assumptions, will cause that it will go from one place to another on end. So a different thing we could do is to throw an exception. And this way we guarantee that nothing below is executed also, but also we interrupt our callers. We make a signal that you did something wrong, you need to be canceled. And it may work to some extent, but it works under the assumption that whatever caused the bug, whatever the source of the bug is, will no longer be visible at the place where we catch the exception. But this is not necessarily true. And there is other point here now. Static analyzer can no longer help us, because now there is no undefined behavior inside. If we pass a null pointer here, the static analyzer can see that it leads to throwing an exception, but throwing an exception is nothing incorrect. You throw exceptions in valid programs. So the static analyzer cannot help us there anymore. We compromise static analysis in order to save something at runtime when it is too late. Okay, this gives us different causes for those null pointers being passed. Maybe the reason for a null pointer is a data race in a completely different part of the program. So what that we throw an exception and catch there when the undefined behavior is still there and is still corrupting our program. So a better idea might be to immediately stop the program. The moment we discover that something is not as we wanted, that our caller didn't understand the interface, or there is some other UB going on already, we just stop the program. And this may look harsh and unacceptable, but it has some advantages. We guarantee that no further damage will be made by this program. And as a side effect, we get a core dump that the programmers, if they get their hands on it, can make some analysis on and determine what the problem is. It may look too harsh, but it's option one should consider, even for the systems where the human life depends on. Like imagine troops having a software that helps some tool that helps detect whether there are some enemies in the vicinity. In the night, you cannot see people, but the tool could detect how many people there are in the vicinity. This tool had better work correctly, and this tool had better not crash, because soldiers' lives depend on it. But so there's a lot of tests going on and a lot of effort to make sure that everything works correctly. But if at runtime we were to detect that the program is starting doing unanticipated things, that we may be operating on random values, the only decision we can have is to shut down and say to the soldiers, sorry, you're on your own. And now you will piss them off. You are risking their lives. But you are giving a clear and very important message. Now the tool can no longer help you. You have to use only your experience. Whereas on the other side, if we were to proceed with some default values or some random computations, we are risking lying to the soldiers that depend on us. We're saying, well, we don't know what happened with default. Safe default is 0. There is 0 enemies in the vicinity. That would be even worse. So it's always an option to abort, even in safety-related systems. And so far, we have been talking about a precondition. So maybe let's look closer at it. Precondition is a predicate, that is a function that operates on our arguments and returns true or false, that expresses a constraint on the input values. We say that we expect this condition to hold when the moment the function is executed. And expect is not formal. So the formal way of saying this is, if it is not true when the function is called, it means that there is a bug in the program somewhere before this function call. Not immediately before, maybe a day before this function or a different part of the application, but somewhere before rather than after the function, which means that, or we will talk about this later. So this function will be executed nonetheless, but if this condition doesn't hold, whatever value we produce is meaningless. We are no longer talking about the offers here, but we are just talking about abstract machine and what it does. Also, because we say the bug is before this function call, when we get to fixing it, it is clear on which side of the interface it needs to be fixed. We don't fiddle with the body of the function, it's okay. The callers, one of the callers has a problem inside them, so this is where the fix should be applied. So the way precondition helps detect bugs is that it defines them formally in a way that other programmers, code reviewers, and tools can understand it, because it's expressions from the language. And if we are thinking about standardizing support for those preconditions and contracts and other contracts in the language, we mean providing the uniform syntax that will be uniform for all the tools and applications that there are in the world. And any particular semantics, like whether they are evaluated, what happens then, are secondary. Our goal is to provide a language for talking about those predicates, the preconditions, invariants, postconditions. So let's see the second example. The question was, what happens if we need to check even integers in the range, but the range has the inverted or not inverted? There are some integers that do not represent a range. And what happens then? And one answer is, well, that there is no UB here, no undefined behavior. So maybe there is no problem here. There will be some value produced. You give whatever ints you get, there will be some computation, some comparisons, some value will be produced. If the caller gives us rubbish as input, they will get rubbish as output. It is not our problem. But it's not entirely so, because now we are lowering the abstraction again. It's not ranges anymore. It's just two integers and some computations. And also, potentially, there will be bugs in the code. Our callers will make mistakes, like, I thought that this value goes at the end because other libraries do it. But in fact, in my library, it's at the beginning. So I may have confused how the order in which the arguments are passed. And we have lost the opportunity to detect this bug in our function. It's not our duty, maybe, but we can help. So we could consider, even though no one asked us about it, and we are protecting against nothing, because from the perspective of the body of this function, we don't have to do it. But maybe we want to check and immediately abort the program to indicate that there is a bug going on. Or maybe we can go even further, and this may look crazy, and just plant UB, even though there was none before. If this condition were false, we just dereference a null pointer, and we cause UB. And this may look irresponsible, but I realize how dangerous UB is and what consequences there are. What I'm saying here is that bugs in the code should be treated equally severely as undefined behavior, because bugs are nothing more than undefined behavior at the level of business logic. In either case, our program does something that we never wanted. But why do we do it? Because static analyzers cannot detect preconditions because they don't know what a precondition is, but they can detect undefined behavior. So with this code, we are going back to the situation. If there is a path in the program that caused to this UB being invoked, the static analyzer has a chance to see it and warn us about it. And other tools like UB sanitizers, which are designed to detect UB, can now detect our preconditions. And of course, this doesn't have to be plain there in the code. We can hide it under a macro, which will expand to UB only if we are doing some analysis or tests, and the normal program, it can do nothing or abort whatever you choose to be the safe default. But luckily, we don't have to do all this stuff, because there is another way, which may be even better. We can introduce a new type, range, which will be two integers inside, so nothing more here. But the range, because it groups these arguments, it gives a clear message what we are doing here, that we are actually using some abstraction like range. And now the callers are forced to type this range. And if they get the order of arguments wrong, Now we get a type system error, and the compiler, not even the static analyzer, the plain compiler is forced to report this as an error. But we didn't actually answer our question, we just restated it. Because what happens if this dot low, because now we have member functions, public, const. But what if this low is greater than high? And this is answered inside the class definition. Our class will probably look like this. We have a constructor, we have these accessors, and apart from that, we are providing an invariant. And this is nothing that the language can recognize, so it has to stay in the comment. But this is a very important information in this class, and in fact, the only reason for providing this class. We are saying that the two integers that we hold are not just random integers, because if they were, we could use stud tuple or stud pair for integers. This class is different because apart from those integers, it has the invariant, even if we have to communicate it informally. And the guarantee we give is that you will never observe this low being greater than high. So you will also always observe that it's less than or equal to high. And in order to guarantee that, we cannot expose those members as public, because then anyone could compromise our guarantee. So they will be private, and we will only get them through a narrower and safer interface. But because it's an expression, the expression itself is expressible in C++, we can declare it as a member function. It will be const, it will return true or false, and whoever wants can invoke it to check whether we are actually providing this guarantee. And in fact, even we ourselves can invoke it whenever a public function is called. We can check, at least in test builds, but maybe also in production builds, whether the invariant holds. And we could use this invariant when expressing the precondition of our function is in range, but it's not necessary because this invariant, this precondition is implied on any function that uses our type. This is actually the definition of an invariant. Whoever uses this function will get this as a precondition. It's precondition guaranteed to everyone around. So we don't even write it down. It's enough that we put it as an invariant. But how can we provide this guarantee if someone can deliberately pass the high and low the other way around? And for sure, we'll later observe this, not the way we want it. So we have to go back to the definition of the class. It will also have a precondition on the constructor. Like this L cannot ever be greater than high when you call this constructor. And only then can we guarantee our invariant. So the invariant is a conditional guarantee. We only, and this is why this is called contracts, because there's two parts involved and we expect something of both of them. I will guarantee you that this invariant always holds when you observe my type, provided that you guarantee that when you call a constructor or maybe some other function that mutates the values, that you will pass me the correct values in. And this may seem like a little because this bug is still there, but other bugs like this one are already fixed. Like this will never happen again, this wrong order of arguments, because now we have a type that binds the two together. We have also fixed another bug. If we manage to propagate this new type range across different layers of the application, the only place where bad values can enter is during the construction. But later on, when all the other parts of the program speak in terms of the range, there is no way anything go wrong. So we have narrowed the scope in the program where the bad values can enter into the system. Like if some functions returned just to integers and the function bounds never thought about this being less than the other one because at the level of bounds they are just two numbers this could happen. But if bounds can talk in terms of range, the only misunderstanding can be inside function bounds, but not outside. Yeah. So now let's get to the third example we've seen. We are computing the length of a C-style string. We know it cannot be null, and we know it must be null terminated. The first thing, the first precondition is easy to express. The second one is in fact not expressible at all. In order to check this, we would have to iterate over all the characters, but if there is no zero there, we will iterate forever and cause some undefined behavior. So there is no way to runtime check it. But there are other options, like we can introduce a new type like C-string, which actually contains this construct star inside and nothing more. So it's the same size, but the name of the class, only the fact that the class exists, sends us a clear message that we don't mean any construct star. We only mean those that represent C strings. So the class definition will again have an invariant, which we cannot express. And observe this. This is interesting, at least. The only purpose of this class is to have the invariant, and we cannot express the invariant, and it is still worth it, because invariant is something we communicate human to human. So we know what we mean, even if we cannot actually execute the code that will check it. And this already handles some bugs. Like if there is function getName that already returns this C string, and my function length expects a C string, there is a type match, and everything is safe. And we know there is no unintentional bug in there. But there will be always some APIs that will use naked construct stars, so we have to prepare for them. Our class will also have a precondition that the pointer needs to be correct. And again, we cannot express the precondition because we don't know how. So as we said, there is no way to check it at runtime, but static analyzer can still help us there. So there is value in trying to somehow annotate formally that we have this expectation. And this is how we could do it. I mean, we cannot do it today, so what I'm showing you in this slide is a fantasy of the potential future language feature. And it goes like this. For sure, the one thing we can do is to give it a name to this function. Maybe we cannot provide the body, but we can provide a name. It's null terminated. And then it will be executed sooner or later. When it is a predicate, it will be executed. So we have to return something. Because we cannot ever determine the condition, we don't want to give false positives. We will return true. True means I'm not 100% convinced that there was a bug. So I just return true in order not to abort the program too soon. But for the purpose of static analysis, we have this attribute. It doesn't exist today, but it could in the future. And it means to the static analyzer, don't look at the function body. It's just rubbish. Yeah, just focus on the name of the function, treat it as a symbol rather than a definition of the function. And what it buys us, first, we can use it as an expression, because now it's a normal function with a signature, so we can use it wherever you can put a function. So we can express our precondition. And the way it would work, hypothetically, if we get just a row pointer, we have no reason to assume that it is correct during the static analysis, so we report a warning that there may be a contract violation here. But if our function getName has the post condition now that it will return this is null terminated. Post condition is a guarantee on the return value. Return value in function signature doesn't have a name, so we have to artificially introduce this R, and then we say that this R is null terminated. if the static analyzer can see this, it can see that the postcondition from this function is exactly the same symbol as we see in the precondition of the other function. So those symbols match, and the warning from the static analyzer is silenced. And this way we have introduced a postcondition to our talk. And this is the primary goal of the postcondition, at least as I see it, is for it to be matched against other subsequent functions' preconditions, and some conclusions from it to be drawn. So let's see the postcondition a bit. Now we have a function that takes two pointers to offers and return better of the two. We have a precondition that we know they cannot be null, and we have a postcondition that the return value r is also not null. And the postcondition, again, is a conditional guarantee. Like, we don't guarantee that it will be true, the postcondition, if our function throws an exception. It's quite obvious, actually, because if there is an exception, there is no returned value, so we cannot even observe it. But we could put it in even stronger words, or invert this property. The primary, if not the only purpose of throwing an exception is to say that we were not able to satisfy the postcondition that we advertised. And the second case where our postcondition will not be respected is when the preconditions are not respected. You can imagine how this function is implemented. I get two pointers, and I will just return one of them. So if one of them is null pointer, you will likely get this null pointer back, and I will still be able to say that I satisfy the postcondition. I'm compliant with the postcondition because the precondition was violated. Okay, so for now, what we've seen was comments in the code, or yeah, and this is mostly the comments, because there is no way, even though the contract, the fact how we interpret the input parameters and what we definitely expect of them or don't or not expect of them cannot be communicated in function declarations. So whatever we do is not really satisfactory. The best way, the best thing we could do, and some people do it already, is to have a macro like precondition that stores these conditions inside function body. And then it does different things with them depending on how we want to configure the macro. So there's some hash if-defs or whatever, and in one build it just checks and aborts this. In other builds it checks and throws an exception, does nothing, logs. There's many options, and they are of course useful. They can help prevent damage to the code if the program is terminated early. They can help in testing to detect bugs. But it all feels wrong because they all allow the bugs to happen. We only have to allow the bug, and then we can do something with it at runtime. What they don't do is they don't really prevent bugs from entering the system in the first place. And this is where contracts in the language could help. There were two attempts to add contracts to C++ so far, one for C++ 11, the other for C++ 20. They both failed, but we are working on a third incarnation. And the syntax I'm showing you was from the second attempt. We don't know if they will look the same in the third attempt, but maybe. So this looks somewhat similar to attributes, but they are not attributes because attributes would not allow this colon there. But the idea should be clear. Pre means a precondition, this post means a postcondition. And if it worked, we have the ability to declare those preconditions and postconditions as part of function signature. It's better than comment because it is something that the compiler can see and can type system check. So it can see whether A, B, R are well, not are, but A and B are in scope, whether the expressions make sense. So they are always compiled and in sync. And the good part is that the compiler or the static analyzer doesn't have to look inside the function body to get the relevant information it wants, because it's all there in the function declaration. We made the assumptions in the previous slide that the function should be inline. Now it's no longer there, because only the declaration has enough information for the static analyzer to proceed. In the case with is in range that we had before, there is no need to inject some code or undefined behavior inside, because the predicates, those contract predicates, extract all the good parts from undefined behavior, but leave the bad parts alone. So the information for the static analyzer is plain here in the text, but there is no UB anymore. And oh, I forgot what I wanted to say. Well, this is there. And even one of the other uses of those annotations is that the compiler can inject some code based on them. So now you can just configure the compiler to put those defensive ifs inside the body only from those preconditions. And even if they are there, this doesn't compromise the static analysis, because the static analyzer gets his message that in form of this predicate. So you can have the best of both worlds. And you can put them in the place where you normally cannot put any code. Like an invariant could be expressed as a declaration inside the class. And you cannot do this even with C asserts, because no declaration, no expression or statement belongs there. And we get to one uniform syntax, because static analyzers that are able to detect preconditions are already in the market. But each of them uses their own syntax for expressing those preconditions. And if I'm writing a library, I don't know which tool I should target with my annotations. But if there is one uniform standardized notation for this, it will be obvious. All tools will have to adapt to it, and I will know how to write my contract annotation. And there is one important other thing that we have to talk about, that static analyzers or UB sanitizers can only detect symptoms of bugs, but not the bugs themselves. Like, if I have this function from one of the previous slides, there is something, it's quite complicated, and the static analyzer says that something is wrong. But it doesn't know what. It doesn't understand our intentions or what this function is doing. But it understands one thing. We never want undefined behavior in the program. And now if we have preconditions, we never want preconditions to be violated. It can be sure there will be no false positive. It's always, if we can find a path that this is violated, it's for sure not the programmer's intention. We know that this is not the programmer's intention, but we still don't know what the intention is. So if we get this warning, if your goal is to have no static analyzer warnings, the thing you could do would be to just put a defensive if and just skip this call to offer if y happens to be null. Because this is what the static analyzer warning would be, that y can be passed a null pointer. Y can be a null pointer when this function is involved. So if you see a warning and you want to be quickly be done with it, you can just silence the warning. But this way, you are only curing the symptoms, but not the cause of the problem. If your goal is not to see the warnings, you can just skip static analysis altogether. But if you want to fix real bugs in the program, you will have to look at all the code before to trace for the real source of the problem. And the real bug here is this premature try and catch. Apparently, we are assuming that compute offer always returns some proper offer, never a null pointer. And apparently the idea here was that we first compute the offers, and once we have computed them, we tell which one was better. So if we cannot compute the offer, for sure we don't want to give the answers whether one is better than the other. So the proper way to address this problem is not to put those catch. Usually putting try and catch is an indication of a bug. It's hardly anywhere in the program that you need to catch exceptions and swallow them. And once we do this, we can see that this defensive if will never be triggered. So we can simplify it a bit. And now, because we have no artificial scope introduced by the try, we can combine the declaration of the object with assigning the initial value. And now, not only did we fix the bug, but also the program flow and logic is simpler, and we have learned something about this part of the program. And that's basically it. Just to summarize, the most important points is that contracts, and especially the preconditions and invariants, that are expressions of the contract, help detect bugs in a formal way that is understood easily by other programmers, code reviewers, and all the tools there are. There are C++ predicates that can potentially be executed, and if there were to be executed and return false, it means we are sure there is a bug before this condition, or in the condition itself, because condition in a contract is also a piece of code which can contain bugs, but never after. And they can appear in the places like class definitions, which is also a novelty. And with this information can be exploited by many tools, like by static analysis tools, by sanitizers. In the code reviews, they can be used for code generation and even more. But this is a different story to be told another time. Thanks for listening. And
thank you.
If we have some time for questions.
Thanks very much indeed. And we've got just a few minutes for some questions. So if you do have a question, please join us here down the stairs, please. Any questions for Andrzej?
There is one, at least.
There is one.
Coming down.
Or even more than one. Here you are, sir.
Yeah, so your pre and post conditions, especially the symbolic function that you implemented to blindly return true, just for the sake of it, to return something. So this kind of reminds me of using type system and type trait. So you could make a type trait in conjunction with C string that would say or implement the post condition to be always true. Have you thought of implementing post conditions and preconditions using type system?
We actually seen this passing this C string class rather than pointers is a way of doing this. It's like engaging type system.
I mean specifically the function which said is null terminated and always set true. So it would be something like is trivially copyable or something like that. So this is what it reminds me of. And similar things are already present in the standard. So how do they differ? That would be the question.
Okay, so the question is, if I understand it, whether the type traits or similar static mechanisms can be used to detect this kind of preconditions. I'm trying to find the slide, so maybe it will be easier to see. The answer is we cannot, because whether the precondition is satisfied or not is a dynamic property of an object rather than type. Type traits constrain the types, whereas here we are constraining the values of the objects, which we don't know in advance. So statically, we cannot say that this value of the object is okay or not. For some minor subset, we could do it if this is context or compile time expressions. There we could use static asserts to detect those bugs. But then we are still left with those situations at runtime, which there is no other way that we know of to handle.
You mentioned that there were 2 attempts to have postcondition and precondition standardized, but they failed. Do you happen to know why the committee didn't agree to have those mechanisms in the language? What were the reasoning to reject those pre and post conditions from the standards?
I think the reason was the same as with other features that usually don't get into the standard. That it was too new, too unstable. There was no implementation available in any compiler that would prove that it works and that we understand it. So we were, because the question is why the previous standardization effort failed. We only think it works. We know that we need it. We only think that the syntax we invented works, but we are not sure. There was not much investigation being done, experimental implementations, and the corner cases explored. So it was too soon. It was felt that it was too soon to rush it into the standard.
Okay, thank you.
Yeah, Andrzej. So, what do you think about optimization based on the preconditions? So, like, imagine you have a function that cannot work with null pointer, but is using somewhere deep inside function that is checking if it's a null pointer or not. So, what is it? Is it something that your proposer is supporting or not?
So the question is
to do optimization based on the preconditions. So, for example, you can remove some of the comparison of null pointer when you know that the function has this precondition.
Okay, I'm looking for a slide. So the question is whether those contract annotations, if there are, can be used for performing additional optimizations in a compiler. They could. People, the answer is they could. People are afraid of those we can call it, after the morning talk, the evil compiler optimizations, because the effects are not sometimes surprising. But we could. We can do it even today. Like, we've seen this. We check the condition and react somehow. If the reaction is just to plant undefined behavior, maybe a clever compiler can exploit it. Of course, some people, there are different industries involved here. So when life-critical systems people see this idea that there will be more UB in different places, they are just absolutely scared off. But yes, the other people, if we are talking about the video games, for instance, it crashes, who cares? But if it's faster, if it's twice faster, this is a benefit. This is a real benefit. So they give you this potential. And because it's in the function declarations, you can have even more of this.
Okay, and the last question, please.
Hello, thanks for the talk. So one question for the example on the slide now. The code that is injected for if not A, not B in this example proper. For example, if this function is passed to the sort algorithm, this function would be called multiple times with the same input. So would there be any optimization techniques that it is not checked multiple times, more times for each value?
So there is a concern, this is how I understand your question, that if there is too much of those checks, it may slow the program down. And is the compiler clever enough to do the optimizations? The way we standardize it, the one we want to standardize it, and the way it works today, it is that it is hidden under a macro. And this is in order to give you the control. We don't know what the compiler will do or how clever it is. So you always have the option to switch it off entirely. So this way you get the guarantee that you will not spend a single instruction doing all those runtime checks. There is a switch to turn all of them all on, and then maybe it's too slow. Whether it can be optimized, I think there is no clear answer to it. I think it depends on how clever your compiler is.
Okay, thank you. And the other one, if we bind a post condition to a value, would that mean that it has to propagate through move operations, assignment operations, and like that? So we have to, when when writing those assignments and constructors to not violate the post condition that has been bound to a value.
So the question is, should I, especially if they are generated by the compiler, should I annotate all those preconditions?
So we bind a post condition to a value, if I got it right, not to a type. And if that value propagates through a program, it is called multiple times, let's say, copy construction, move construction, assignments. So what if one of these violates the post condition we have put on it?
I don't think that I understand the question. Like, if you have a copy constructor of a type that has an invariant, because I think this is interesting.
No, not the type, but the value.
So the value is returned from a function.
Yeah.
And the function says that something about this returned value.
It binds some post condition.
Yeah, and you know that this is guaranteed only for a tiny fraction of a second, only the moment the function returns and not after. And now I fail to see what the question is.
Yeah, if that tiny second, okay, the answer is that it's there for only a tiny second. I wanted to ask whether it propagates through a bigger part of the program.
No, and you can only assume it the moment the function ends and not after next operations are involved.
Andrzej Krzemieński.
Thank you.
Just a very quick one. If you are hoping for Dominik Deja's speech on contrast digitalization at stage 8 for session 5, he's not going to be able to make it. So instead, we'll have Bjorn Fahler delivering modern techniques for keeping your code drive. So that's stage 8, session 5. And since it's already past 1, this is 1 hour lunch break, 1 hour lunch break. There is no food in this venue, but plenty of places within a walking distance, very reasonable ones. So do have your lunch and we'll pick up at 2.
Zjadłeś lunch? Tak. Dobrze. Bo już się wystraszyłem, że wiesz, ty odwaliłeś robotę, a ja sobie poszedłem na lunch.
Nie mamy zastępczego klikera?
Niestety nie mamy, nadal nie udało nam się znaleźć klikerów, które mieliśmy w zapasie, ale gdzieś są w
So welcome back. How was lunch? Good, good. So this is Code Dive Day 1, Session 4. Just to remind everybody, this brief announcement about Stage 8, Session 5 at 3:30. The advertised Dominic Deja and his contract digitalization is not going to happen, unfortunately, but replacing him will be Bjorn Fahler with modern techniques for keeping your code dry. The second announcement is, I don't know if you noticed, but there's quite a numerous bunch of people at our conference sporting bright red sweatshirts. Now, this is nothing to worry about. These are people who keep coming to Code Dive in ever-increasing numbers, and they come from this country that is called Holland, now being renamed as the Netherlands. And they all come from Utrecht. Now, if you're a Dutch person coming from Utrecht, say Utrecht. Told ya. So let's return the favor, and if you are not from Utrecht, say Wrocław. Thank you very much. Welcome, everybody. Now, our next speaker is Tomasz Skowroński. He has been a software engineer for over a decade with experience in a wide variety of systems, from mobile to financial. He is a Java virtual machine languages enthusiast and the application programming interfaces explorer and traveler. Privately, he's a friend of penguins and androids. He likes city bikes, he likes podcasts and audiobooks, and this is really private. He's got one allergy and 2 addictions. He is allergic to Java beans, but addicted to good coffee beans and clean code. And his talk is called Resilience Patterns in Practice. Let's warmly welcome Tomasz Skowroński.
Hello. I should start with some boring explanation, some boring definition from Wikipedia, maybe some quotes from the famous person, maybe some another boring diagram, but instead of that, to explain what resilience is, me and Christopher Nolan, especially for you, prepare over 3 million of resilience examples just in 2 minutes movie clip. Let's check it.
The enemy tanks have stopped.
Why?
Why waste precious tanks when they can pick us off from the air like fish in a barrel?
There are 400,000 men on this beach.
coming back round. He's coming back round!
Where are we going? Dunkirk.
I'm not going back.
There's no hiding from this sun. We have a job to do.
If we go there, we'll die. You see it from here. What? Home.
Developers from the British Expeditionary Force, you are here in Dunkirk and you are surrounded by the enemy. There is only one way to survive, the sea evacuation to your home country. There is only one way. But we don't have enough warships and the bay is too shallow. It's time for Operation... It's time for Operation Dynamo. You need to use little ships of Dunkirk, over 850 private boats. They are available to you via Boats API. But please, use this API in a responsible and resilient way. Good luck. Hello again, my name is Tomasz Skowroński and today I will tell you not only how to survive on the beach or on the sea full of enemy fighters or bombers, but how to survive in a world of resilience patterns. I am a Java developer, so don't be surprised with Java examples of these patterns, but resilience topic is more and more popular. If you heard about resilience, you have to heard about Hystrix, the most popular library in Java. There are more of them, probably for each language. There is also resilience for JS, for JavaScript. So you can find components probably for any language implementation. With Hystrix from Java world, there is one problem. Hystrix is that he is no longer under active development. It is in maintenance mode, and only security patches, if they will be applied. So there is no Hystrix more, but there is Resilience 4J. It isn't official successor from Netflix, but it is even more and more popular each day. Resilience 4J in contrast to, is very lightweight library. In contrast to Hystrix, it has only one dependency, not three. This dependency is a waiver. It is a functional library for Java, but it isn't part of public API, so you don't need to know or use it. Resilience 4J promotes decorators and functional programming. But even if your software isn't written in this paradigm, it isn't a problem, because it means that Resilience 4Js reuse common functional interfaces, like function, of course, but also supplier, consumer, future, runnable, callable. And what is good, you don't need to implement them directly, because you can provide Lambda or method reference. But let's begin with first component, first pattern. Do you know this feeling when you... Sorry for order. Do you know this feeling when you stay at the end of the very long queue and ask, why does it always happen only to me? If yes, probably you should think about time limiter. What time limiter is? You can think about it as if it were a timeouts factory, because you can apply timeout to probably anything. Why do you wanna do it? Because you don't want to wait at the failing forever for no result. But wait a moment, isn't a timeout exception some kind of error? Do we need timeouts factory? Yes, it is. But let's imagine what will happen if you don't have timeouts. If you have time, you can check and wait and wait and check what will happen. But we don't have time. We can check how it works in practice. Each Resilience4j component needs 3 steps from you. That means you need to create configuration like this one. Of course, you can use default values, but it isn't a good way. Even you know what are the default values, probably guys from your team don't know them. So always try to write the values. Like here for timeout, only what we need is a timeout duration. And when we have configuration, we can simply create our component, like here, time limiter. There is our business logic. It do only waiting, 42 milliseconds. And what we do next is to decorate this, our code, with created before time limiter, here. And it is obvious then this time is below our settings. It will be successful. In other case, like here, there will be failure. So even there is no native timeouts, for example, from HTTP client, we can add it in simple way. You can ask, what is a try? Try is a monad, like an optional. But in case of error, it isn't empty. It contains the exception, the reason of failure. Why do we use it? Because without it, we need to write code like this. We don't want to do it, so it is better to use try. And from try, we can get the value or the exception. It depends what is inside. This time is also about time, but here now time has different meaning. In case of rate limiter, we also limit the time, but not the duration, but the number of executions. But be careful, not parallel executions at the same moment, only executions at the same time window, 1 second, minute, or even hour. So you can think about rate limiter as if it were a throttling factor, because you can simply apply limitation for number of executions at the same time. What throttling is? Let's look at the picture. There are blue lines on the first plan. There is no throttling, so you can see that the limit is natural. There is no limit. Yes, it only depends on your credit card. But when you apply throttling, there is a limit of 1,000 per each second. So you can be safe. For example, in case of DDoS or any other. Let's look how it works in practice. Here we also start with configuration. We allow to only 1 executions per each 2 seconds. And here we apply this rate limiter to our business logic using this method. Here you can see that where is this functional way in Resilience4j, because you can implement any functional interface from this list and simply integrate with your code. And here, as you can see, there are 2 calls. and they aren't at the same time. Yes, they are one by one, but in the same time window. And the first one is of course true, but because we allow only to one call, the second one is false, is failure. Second example is more interesting. The configuration is almost the same, but here is the difference. There is timeout duration. There are also two calls, but let's check how it works. And both are successful. Why? Because we still, even if we still allow to only one call per each 2 seconds. Let's look here. First call is successful because we allow to one call, but the second one was delayed 2 seconds. It is the reason of this timeout. Sometimes we don't want to reject unexpected calls. Instead of them, we can move them to the next time window and execute later. Sometimes it is good, sometimes it is worse than rejection. Retry is also resilience patterns. It is simple like a timeout, but so sometimes we often forget that it is also a pattern. It is simple, but it is tricky because we often forget about good configuration for retry. Retry, of course, repeat failed execution. So if there is successful, there are no more attempts. In other case, there are retry. How many? It depends on configuration. I would say 1, 2, or even 3 is good enough. No more repeats, no more attempts. If you don't want to wait more for, because if something doesn't work, it won't work probably soon. Maybe it will work soon, but later probably no. It is better to reject these executions. Default interval function for resilience for J, that means function that it's a time between each next attempt is constant, but probably you should think about another function like interval, like expressional backoff, because if something doesn't work after 2 seconds, maybe it is better to check it after 4 seconds and 8 seconds, not 1 by 1 second. You can see it on the picture. In our test, we allow to 3 retries, attempts. As I said, I choose better function for this interval function of time, but there are other of them. Maybe you wanna use some more random. You can of course provide a values like a base value and time between each next. You can write custom function. And what is nice, this retry component can be even smart. That means you can configure, like here, when it should retry. Because, for example, like in our case, when we use both API, that means HTTP client for both API. If we receive 500 or even higher status code from HTTP, it means, oh, there was a backend exception, let's retry it. But if you receive 400 something status code from HTTP call, it is a client error. That means, hey, you sent me a bad request, or you sent me request on not found path. Don't do it again. There is no sense for retry. But there is one status, that means 429. It is using for throttling. So if you do too many requests, server should reject them and send you this request. And it is good reason to retry. Maybe the retry will be in the next time window. So server errors and throttling status, that means too many requests. will be supported by our test. And our server is just a mock. That means if path ends with 500, we always respond with server error. If path ends with 400, we respond with bad request. And the first example is obvious. That means we try to get our boats. We decorated it with boats with our retry component. But because server always fails, we always receive errors. There is no success. But there, as you can see, there is only one call. But because of retry, there were 3 tries to get this boat number 500. And there is another exception, another case. We try to get also non-existing boat, but as you remember, in case of 400, we respond with bad request, and because our retry is, let's say, smart, there are no more retries. Only one try there was to get this boat. Here, in this example, you can simply see first very simple version of fallback pattern. If you can use try monad not only to wrap executions and wrap exceptions, but also for this kind of work like this, you can provide alternative value, some kind of fallback. So even there is always error from backend, here we say, in case of error, try to recover, use some dummy default boat. And as you can see, the result isn't null, there is no exception. Bulkhead, but this is my favorite example. What bulkhead do? It works similar to rate limiter, but instead of time windows, instead of periods, it limits parallel executions at the same moment. So time window is 0. It is commonly used to protect resources, to create a resource pool. What is bulkhead in reality? There is an example of boat, because bulkheads are used not only in IT, but also in boats or docks. And there is example with bulkhead. You can see that bulkhead is some kind of inside wall to partial protection of all, like our resource pool. Now, please imagine this situation. One boat, 20 people, and only 4 paddles this summer. And now the same, but for people without imagination. The same situation explained by code. There are our constants. That means we have only 4 paddles available. There are 20 people on the boats. And we have 2 methods. Paddle now, when we try to get paddles from the resource pool, use them, wait 100 millis, and return to the pool. And method everybody in the boat, when we create 20 threads, start them at the same moment, and run our paddle now. That means we create 20 tasks, start them at the same moment, and everybody try to get this one of these 4 paddles. So let's see what happened in first naive version when there is no protection. You can see that there were created and executed 20 different threads, and the number of available paddles was not between 0 and 4, but often below 0, what doesn't make sense in real life. If we try to synchronize our paddle now method, here, there will be some kind of protection, but First, there were still 20 different threads, and all try to get paddle and use them at the same time. The number of available paddles was 4 at the beginning and 3 later. Why? Because of synchronization, we allow only to one thread to access our resource pools. So 3 of them are never used. So it isn't good. Let's use thread pool bulkhead. Like in Hystrix, in Resilience 4J, there are 2 isolation strategies: thread pool based and semaphore based. Let's use first of them, configure. So we say we allow only for 4 threads because this is number of our paddles. Let's see what will happen. And it doesn't look wrong because you can see that there are a lot of executions. There are only 4 different threads. They were created, 20 of them, but only 4 of them try to get our paddles. And the number of available paddles is between 0 and 4. What is good? Why do we have too many executions here? Because thread pool bulkhead use queue under the hood, and the default value is too high for us. We can decrease it to minimum 1, but still you can see there are 4 plus 1 executions. So maybe semaphore-based bulkhead will be better for this case. And yes, it is the answer. Even though here we create 20 threads and start them at the same moment, because of our bulkhead, only 4 of them, what you can see in logs, only 4 of them are accepted to get access to our resource pool. Okay, fallback. I showed you very simple example of what fallback is, but maybe some more examples will be great. First, this picture, as you can see, if you remember from the movie, sometimes it is better to receive even a boat that can't swim. Maybe some more like IT example. Let's imagine you are VOD platform. Let's say HBO Go. And if some part of your system doesn't work, then nothing worked. So it wasn't best example of resilience or fallback. Let's imagine you are Netflix and some of your components, some part of your system doesn't work. For example, recommendation service. It doesn't work, but it doesn't mean that you can't display recommendations. You can provide fallback. For example, the list of the most popular movies is good enough to be replaced instead of recommendations. The most of people won't see the difference, and it is better than exception or empty list or some other unexpected result. I will show how works fallback in case of extension for Fein. If you developed for Android, probably you heard about Fein or retrofit. It is a Java library when you can create HTTP client just from the interface, so in very declarative way. Normally, to use Fein or retrofit, what you need is to create HTTP client from interface like this. Here is the configuration of the serialization, and here is our interface. So you can see there is no implementation. We only configure what should do call to this method. That means it means get at this path, and the same here. And when we wanna add resilience 4J for this, we can do it in this way. That means we can add circuit breaker, fallback, or even rate limiter. How fallback works here? What we need to do is to provide alternative implementation of this interface. So our fallback looks like here. Instead of error or null or null, we provide empty list of boats. Instead of exception, error, or null, we provide some dummy boat, our live raft. And again, our fallback is smart enough. That means we only serve it in case of server error, no client HTTP error. And you can see here, even though we try to get non-existing, and what is the reason to use this extension for fine or retrofit? We don't need to decorate each method of this interface. Of course, there can be more than 2. We can decorate all API, all HTTP client once, and now each method has a rate limiter, fallback, or circuit breaker. And like in this example, we try to get non-existing boat. So there should be some exception or null, but we can get its name, and it is our fallback value. And there are more of extensions. That means even you don't feel good with decorators and functions, you can use in Spring Boot, for example, the most popular framework. You can use annotations, you can use configuration in static file, or there are more of them. And metrics. There are free implementations for metrics. There are very important for resilience because you need to know what would happen under the hood when you use a retry or other components. And circuit breaker. So if you heard about hystrix, you can know what circuit breaker is. If no, I will explain. The main aim of circuit breaker is to prevent failing executions. But because we can't know when call is failure, we need to provide some try, and after some time we can decide, okay, our backend doesn't work, it's time to open circuit breaker and stop the backend, or open circuit breaker and stop the backend. So you can think about circuit breaker as if it were a failures cache. Normal cache only successes, but circuit breaker works like a cache for failures. So it is opposite of retry, because with retry we do more attempts, more calls, more executions, but with circuit breaker we block if backend after this, under this circuit breaker doesn't work. Let's see how it works. But before, let's remember this picture. It is not only logo of Resilience4j, but it is also a diagram for finite state machine, because each circuit breaker is a finite state machine. There are 3 important states: closed, open, and half open. We start with the top of them, that means close. When circuit breaker is closed, our service behind this circuit breaker works in normal way, like without circuit breaker. So what we have here? We have our server, our boats API. We create a circuit breaker here. I will back for details of this configuration later. And this line is interesting. Each Resilience4j components provide not only metrics for free, but also emit events. And these events you can use for more metrics, but you can use them also for example, for assertions in test or for logging. So here we collect our events, and then we can verify what was the history of this circuit breaker in assertions. And here we try to get our boats, decorate it with circuit breaker, and call a lot time. We call our decorated method with circuit breaker 10 times, wait some short time, and call it again 4 times. So what will happen? Because our server is mocked, it always responds with error. So you shouldn't be surprised. There are only error answers from this backend. After 4 calls, our ring buffer in closed state is full. This is from our configuration. Here we decide that 3 is enough to decide does our server work or no. In reality, of course, it should be higher value, like 100, maybe 1000. It depends on the traffic. So when the buffer is full and when there are more failures than successes, default threshold is 50%. In our case, there are only errors. So our circuit breaker move from the closed state to the open state, the second one. And in this state, when circuit breaker is open, no more calls are permitted. Everything is rejected. No any call won't reach the backend. And how long? It depends on configuration. After short time, our circuit breaker switch to a next state. That means half open. And in this state, we allow 2 checks. That means 2 next calls are permitted. And why? Because we want to check does our backend behind this circuit breaker work again or no. But because in this test our server always responds with error, our circuit breaker switch again to open state and no more calls are permitted. So we were here and we now are here again in open state. So as you remember, there were 14 calls to our backend via circuit breaker, but only 6 of them were permitted. The rest of them, after some time, after when we had enough knowledge to know the backend is disabled, should be disabled, rest of them were rejected. Only 6 from 14 calls was permitted. Why do we need circuit breaker? Let's imagine if our backend doesn't work or some external service, probably it needs some time to recover. Maybe load balancer needs time to switch to another node. Maybe some service should be restarted. More calls, especially one by one, isn't best to solve this problem. If something doesn't work, we need to decide, do we want to use retry and try again? Or maybe we want to prevent unexpected calls when something doesn't work and use circuit breaker. There are 2 different ways to handle this problem. Cache. Cache is also supported by Resilience4j. Of course, there is no new implementation of this of any cache. Resilience4j use common definition, so we can provide any of this or another cache. I won't show you how cache works because it is obvious and everybody knows. Even though naming and cache validation are the most hard things in IT, what I want to show you is how you can connect more components. Let's imagine we have not only circuit breaker, but also retry and cache, and how to connect them. First, you can nest everything. It looks like advanced solution, but it isn't. It is very unreadable, so don't do it. You can write everything explicit. We have our method call to our getBoats to our from our API. We decorate it with retry. We decorate it with circuit breaker, and we decorate it red cache. It isn't bad, or it isn't bad idea, because everything for resilience4j is a function. So you can use we can use compositions and each next layer, each next decoration compose like a next function, and at the end apply. Or we can use some decorators builder and add each pattern, each component by line by line, and it is probably the most clear and best solution. What is interesting, even we apply with this order, that means we add retry, circuit breaker, cache, the order of execution is in reverse order. That means first we check is any value in the cache, later we check what is the state of circuit breaker, then we check should we retry or no, and at the end there is a call for our API. You can think resilience patterns aren't too hard, because they aren't. How they work is simple, what I showed you. Topics is, I would say, interesting but simple. It is simpler, of course, than 8 days of bunker evacuation. But it is only because, first, I showed you only some basic resilience patterns. There are more of them, and probably you can use, and I'm sure you can use them not only on code-based layer, but also on higher layers of your systems like containers, service mesh, API gateway, or even cloud platform. And what is more interesting, okay, they are simple, but only because the question doesn't sound how they work, but when to use them and how to connect them with your system, how to connect them with other components. What should we remember after this talk? Nothing from this list, but it is good to know that the shortest boat used in bunker evacuation in Operation Dynamo had just 5 meters. So what should we remember from this talk? First, don't apply every pattern, and not especially in wrong order. For example, let's imagine what will happen if we connect retry and circuit breaker. It doesn't make sense. Don't decorate everything. Not because you can also use annotations or because you can use extensions for some library, like in this Fein example, but because sometimes it is better to fast fail than fail safe. Sometimes it is good to see then something doesn't work. Not from logs, not from metrics, but from UI. From a user point of view, it is better to know when system doesn't work. Fallback isn't a universal answer or circuit breaker. And use metrics, but not only because they are for free, not only for colorful dashboards, but because you need to know your production. You need to know values of throttling. You need to know mean value of retry. Why? Because you need to tune your resilience configuration. And even my examples were related to HTTP client, this both API example. It doesn't mean that resilience is only for HTTP clients or REST. Almost everything what is unpredictable, what is unstable, everything what depends on time, file system, network, or threads is a good candidate for a resilience protection. I'm waiting for your feedback on the conference website. There are 2 more action buttons for you. And it is all from me, just 2 words at the end. Developers, please forget about Agile, just be resilient. Thank you.
Thank you. If you've got any questions for Tomasz, please join us here downstairs and he'll be happy to answer your questions about resilience or Dunkirk for that matter. Whether you're wearing a red sweatshirt or not. Space is here. Any questions, please? Three, two, one. Let's let the audience think about what you've just presented then. Ladies and gentlemen, let's thank again Tomasz Skowroński. So the usual break, and the break is going to be slightly longer, so almost 45 minutes. So the next talk is going to take place at 3:30. So please do come back no later than 3:30, please. Hello again, welcome back to our next session. Just a quick reminder that you can comment and rank the talks on our website, Code Dive 2019. And with that, I'd like to introduce our next speaker, Nokia's own, based here in Wrocław, Remigiusz Michułka. Remigiusz started his IT journey as DevOps and network engineer over a decade ago, and then moved to designing and implementing various systems and solutions. Today he helps implement best practices in Nokia products and also 5G. Remigiusz sees himself both as an engineer and creator and keeps asking those questions how and why. He's a microservice evangelist and never shies away from any technology. His talk is called Practical Aspects of Microservice Architecture. A round of applause, please, for Remigiusz Michułka.
Thank you very much for this warm welcome. I'm here to talk about microservices. So let's focus about the microservice architecture today. I came here to pour my knowledge into your heads. Why and how? Because of this lecture, and especially why? Because I want you to learn from my experience, from my mistakes, so that you don't have to recreate the pain and lose as many hairs as I did when I had to learn this. So this is my face in color. If you haven't seen it, you can find me after the lecture so we can talk a bit more and more about more details regarding architecture. So the microservices evolution. This is something that you're all experts in. No? Okay, so imagine that at lunch you would like to use a fork and a knife separately to eat, or you would like to have some sort of Swiss knife with a fork, with a knife, with a toothbrush to use afterwards, and a brush to use it to clean the toilet. So, no, see, you're microservices experts. All it takes is a bit of common sense. Now, is it something new? Is it just a buzzword? Is it something that we all know? Yes, we do, and it already happened years ago, because this is an evolution of practical needs. This is the latest, and my most favorite is the Unix philosophy that can be used to describe microservices today. And it's all about writing programs that do just one thing and do it well. And you also assume that these programs should cooperate together. This was composed back in the days when we had to build bigger and bigger operating systems like Unix, and programmers noticed that you cannot build just this one huge blob and expect it to work on every system. So they had to decouple, to split, but the programs, the applications still had to work together. And we know this, and this is something that we have as a given today. Microservices is just another evolution of what we already know. So keep that mindset. Now, what is the core of microservices? I would say it's loose coupling. And what is the loose coupling? The loose coupling is that you don't care what the other service, the other domain, the other party is having internally at their home. So that what you focus on only is the service of what the domain can provide, what's the data they return, and what they do for you. You don't look into behind the curtains. You don't care about that. All you care about is the service. So as far as I see, the service that provides me the things I need, there can be dragons behind the curtain. I don't care. To go through these presentations, I will use a very simple yet non-trivial application example. So we will decompose this application that we can use to order food to our fridge through a simple system and web UI. And I decomposed this into order, fridge, and food, which are simple domains providing different services that we require, and they're stored the data. They are owner of other owners of their data. The databases are not shared, so it's isolated. All the communication goes through interface. So what we can do is we can check the food details, we can check the fridge details and its contents, and we can order the food through a separate service that's called the order. When the service finishes the processing the order, you will get the notification about the food is being ordered, and this way fridge knows that it should update its content. As a side effect, you will get email order summary on your email stating what you just did. This can be written in one way or another. So we can have this separately like we did in here, or we can have this ordering capability in the fridge so that our service called fridge provides a nice way to order items. What's the difference? In here, we need to focus on ordering food to the fridge to this separate order domain, and it has to have a knowledge about the fridge. On the other slide, we can see that the ordering is done through the fridge, and all that business logic is there, and the order is in fact just generic system that orders an item. It doesn't know anything about ordering a food. It's just a simple generic. So these are simple microservices that we have. So we decompose this one monolith that we had into separate services with separate deployment. Keep that mindset that these are services that are separately deployed, it's still a one big system that we need to look at from the big picture. The core of the system is the contract. Because we have so many services and we have so many interactions, we need to have the contract on the paper. What it means that the contract between the services is in fact a third party. So it's a separate artifact. So it's something that we can have even without the service implemented. This is something we compose and we describe. What are the interactions, what are the functionalities, what is in and out from the service, and this is a separate artifact and separate document that we need to focus on. Why? Because everything is distributed. We need to know the relations and we need to design those relations. You will not always get it right, but you have to focus your effort on that. Now, let's go through system aspects, because while it's decomposed into small, separate elements, maintained probably by different teams, having different databases, different technology, it's still a system. So it's still an application that can serve as a black box to the client. So we need to look from a client point of view, and we need to look at this application as a system. So we need to analyze this way. So implement small things in your services, but think about the entire system architecture. The core and the most important thing that I find, and that saved me a lot of work and a lot of pain and a lot of hairs, is the feature introduction. The feature introduction means, how do I implement something in my system without breaking it? How do I control the inflow of features and changes in my system when it's distributed and everything can be separate without breaking it? So it's almost as just fueling a flying airplane, because you cannot just switch off the entire application or just swap one infrastructure with another as you would do with a monolith application. You need to think about this, and to think, you need to have a process. I know, more processes, more paperwork, but it's not about the process itself, but it's also about how you do it. It doesn't have to be complicated. It can be very simple. So this kind of a process is called blueprint. You can call it wherever you like, but I like the blueprint name. And it's a simple process that shows us what we need to do. So at the very top, we have feature scope, and we have business rationale. What does it mean? It's what we want to do and why we want to do something. Even the why is more important than what, because you might know what to do, but is there a real reason why we should do this? It will protect your system and your application from so-called nice-to-haves. I hope everyone knows this nice-to-have feature that client wants that is hard to implement but brings no real benefit to the system. So you will not be the first one and not be the last one. When I say that nice-to-haves killed so many systems already, and just remember that to implement something that you have a business rationale for. Next, when you know why and what, you can look at the system as a black box. So you can have the system user story that will show you this big picture of what you want to implement and how it affects each domain and how it will impact your system's business capability. So what do you really want to do and how you want to do it in terms of your interactions. This will tell you if you have enough domains, if your composition is right, if you have enough services, and if your infrastructure is good enough and big enough to facilitate such scenario. When you do this, you need to decompose into services, so-called stories. The service can be the service that we had at the beginning, or it can be some piece of front-end that you need to implement as well. So when you decompose to the stories, you know how each service is being handled, how the interaction between services is happening, how the feature is implemented by each of the separate services. At this point, you will notice that services use something and they interact with each other, and there's interaction between services or front-end and service. And you need to write that down. This is very important that you understand this story and you know what's the result of this story on the service. As a result of this information, you will have API contract. So this third-party artifact that you will have as a document, documenting what you really want to do and how you want to do it in terms of interface. So it might be surprising for some of you that I want to have an interface representation before the implementation. So this is very vital that you realize how this will be on the paper, documented API, before you start implementing. At this point, you will have end-to-end tests. Yes, that's the moment that you jump in with TDD, and you will write tests so that you can verify the feature before even implementing the first line of code. This way, you will know and guard your feature. You will know that what you wanted to implement is implemented. Then you can proceed with internal changes. When everything is approved, you can proceed with internal changes, and you can start looking for technology at this point. So our API contract is the result of our API contract is the result of our business decisions, not as a result of the chosen technology. But beware, there are certain things that you need to look at. Building distributed monolith. What does it mean? That means that I have decoupled everything that I needed. I have so many services, but they are so coupled together that instead of having a nice microservices architecture, you just replace the class interface in your given language with JSON over HTTP or any other interface that you will choose. So beware of that. If something is closely coupled together, maybe it should be a single domain. Think about that as well. Don't have features that are too big. So don't have everything in one blueprint. Try to separate on a same level, to separate features and separate items so that you don't have too many system scenarios in a feature. Beware and be aware that API contract is the result of business decision and business design, not your implementation. So you might love your framework, you might love your language very much, but don't start with the technology and the team, start with the business decisions. This can be a compromise as well, because you might hire some new people, get the new technology, but still focus on the contract and focus on the business. Store this document. Store the blueprint, have it linked and have it reused. Now let's focus a bit more on the interface, because there's a bit more to that than it seems. I already mentioned that it's a document, but how to write a proper document? What are the ways to define these documents? You can use it. You can use many approaches. You can use it in many ways, but there are certain things that you have to have in your document. One is the composition of your so-called story, however you will describe it, that you want to get the fridge details, and then you need to have the interface operation, so that it's in fact an interface operation in the given interface that you will choose, given form of this interface, so that it can be it can be learned and it can be understood by machines when they read this document, not only humans. So it's not only Word or PDF document, it has to be machine-to-machine document. This way, like for our example, we have get on some URL, we have post to create order for the food, and we can also send an email through the post to the proper URL. And we also have something that's a bit additional. We have events. So it's not HTTP or REST API related, but we have events. And those events can be in different form, documented in different other documents, like some event schemas as well. So it's up to you what you will use, but first have the action and approve the action name and the URLs, and also have the resource schema. So it's the form of how your in and out will look like. This way you will immediately see what are the properties of your object that is being sent, or the data that's being sent. At the very end of your document, you need to have the dependencies. So you need to have some sort of links that you are using, and you're sending references to different objects through your API, like to order a food through the order component service, we need to provide a reference to the fridge and a reference to the food item, so that it can be compiled together in the order. So that kind of dependencies needs to be written down and guarded. So what's the form that you could choose? One of the forms that I personally very like is the Swagger. Who knows anything about the Swagger and Open API specifications? Yeah, I don't see too much through the lights, but I can see some hands in the air, especially my team. So I'm very glad that you know about Swagger, because it's becoming more and more popular. And what are the benefits of the Swagger? And what is the Swagger for those that do not know? It's the API documentation in YAML and JSON, or JSON. It doesn't matter. But it's a way you describe your API through set of rules, so that it's well-defined and understood. What are the benefits of having this sort of documentation in Swagger? Well, the entire ecosystem. It's not just a specification language. It's an entire base of system software applications that can help you. Help you how? Like to introduce left shift practices. Left shift means testing as early as possible. And this means that you can start writing server mocks and generating functional tests just based on the artifact, based on the API documentation. So you can write the entire front end, the entire client application, without implementing any of the server side, of the backend side. This is very beneficial when it comes to separating the workload. So other things are like common code changes can be implemented, so that you don't have to write everything from the scratch. You can generate some of the client code based on the Swagger. The Swagger generator provides a variety of languages that it can generate those, so it's not a problem. You can even generate with a limited pool of server mocks, server schemas, so that you don't have to write down something you see on a different piece of paper and do human mistakes. You can just have it generated. So it enforces a focus on a business representation. And this business representation is also on the paper. So I don't know how many of you are programmers, developers, but I assume most. You know that feeling when someone is just describing something to you, how the class, the function will work, and you say, hey, okay, but only when you see it in the code, on the paper, you know that something is fishy, that maybe with words it sounds nice, but when you look at the code, you see that, I would do it in a different way, or maybe it's not clear, maybe the business, it's not okay. This is the same with Swagger. That's why I advise you to write this down on the paper. When you have enough experience with that, there's one look at the Swagger and you know that something is wrong. It's the same as having having a code, and you can look at someone's monitor from very far away, and when you see a code going like this, you know that something is wrong, even without knowing the language. So that kind of composition and that kind of elements will help you, especially the Swagger. So serious part of microservices that you need to be aware of is the split responsibility, because you might have amazing interface and you might have everything well documented, but if you design the system wrong, then you will pay the price. Well, people, maybe even people after you. So let's look at the two examples we had at the very beginning. So on the left side is the system where we have a fridge using generic order interface, and on the right side we have this first implementation when we have order and the fridge on the same level. So the client is using the fridge and the order. So now imagine, you can see what are the dependencies. You can see that something depends from something, something is using something. But now imagine that on the left side, the order interface needs to be broken. What does it mean for your infrastructure? How your blueprint would look like? You would have to change the fridge. I mean, you don't have to, but imagine that you have to, because the interface is broken, and not because of someone just having a change, but because it's business related. So it's business impact that you need to break this interface. So what do you have to do? You have to update all the interfaces that are using, services that are using the order. So now you have just one fridge, but multiply that by 100. You've seen the decomposition. You've seen how it can grow. So not all the classes, but all the domains can grow and grow and grow. And then you will have this one dependency because you created this way with this one domain, and you will have to affect all of those services. That's quite a lot of work. While on the other hand, I'm not saying it's any better, but from this scenario when the order interface changes and we have a separate order domain for the fridge, or the URL for the fridge, then that's just the fridge features that are affected. This way, we can mitigate the effort. So think about how you split your system, not only how you design, but how you split, because it might impact you in the future. So my advice is design for the worst. So design so that anything can change, anything can be broken. Play these scenarios in your head. These scenarios, like alternative scenarios, can be part of your blueprint design. So have that thought process during your designing process as well. Now let's go to the testing. Who's testing their code? So who's testing? Everyone? Oh, I don't see the entire hall. All right. Okay, so everyone are doing the testing, right? Who's testing? Who's doing testing as a continuous part of their development? So for me, developing means testing mostly. So verifying the code. And to do that efficiently with microservices, you need to automate. And I don't mean automated tests. I mean the automated pipeline. So the entire circle that you might know from any other sources, and because it's similar, it has to be automated. And I don't mean that someone will just trigger something. It has to be from the moment you press merge on or approve a change, then it will go and be deployed on the production. There are companies that prod or shift to production, so publish to production every 10 seconds in their microservices infra. So have that scale. Have that scale in your mind when you automate everything. So not only the design blueprint is the initial element. So for us, the automated part would be to having a Swagger. And then you can implement the feature. And when you press the merge, you can you can validate the feature. So your pipeline is helping you when you develop, when you design, and when you have to validate the feature. So each service needs to be validated separately at this point. Then you need to integrate all those services that you have and see if they work. Not only in some separate infrastructure, but probably also in a pre-production environment, which is close to production. So think about the scale. Think about how your monolith application would be tested and how it has to be done with microservices. It's another cost. It's an additional cost, but there are also benefits because you put in a thought process into how your pipeline, your developing pipeline, it will look like. Then you need to deploy. And it's not about just restarting one application, like pushing code and restarting the application without any downtime. It's about injecting just one service out of many, and they still need to work. So deploying a breaking change with microservices is very easy. You just add it, you add it to the service registry, and it's visible and can be used. Even if there is no client, it's still there and can be used. But when you have non-breaking changes, so additional features that can be discovered and used, and client is expecting that every deployment, because you can deploy the same service many times, every deployment of the service is providing the same contract, even the additional non-breaking features. So that kind of deployment gets complicated, and you need to be aware of that. You need to automate that process. This means additional work. I encourage you to use gating, like Zul CI, they use in OpenStack, so that you define your pipeline end-to-end and all the dependencies and ins and outs in a way that's clear for everyone. So it's not a connection of many frameworks. I mean, but it might be a connection of many frameworks, but you will have this one view of what is happening with your pipeline. And you need to test. And about testing, it also gets complicated. So with your monolithic application, it might have been simple. So you have some UTs, some component functional tests, and then you can push to production. But with microservices, you first need to test the libraries. So then you have to shift the libraries to be used by services. The services needs to be tested separately, and with component and functional tests, these can be generated, and then you have a system. The system needs to be integrated together. Even the services that are not being changed have to be retested because there might be dependency. So see, the dependency part in your interface, really helpful in that, so that you don't test everything, you don't bulk up everything on the stage, but just some bits that are affected. And then you have to test end-to-end. So if you change something in the backend, it would be nice to test also all the applications that are related. So this pipeline can take a while. Security. Yes. Who focuses on security in their companies? Or is it a separate field, or is it just a byproduct of what you have noticed during development? All right, that's an open question. So think about this, how you and your company focuses on the security. Why? Because with microservices, everything is a security issue. Why? This is just to show you what are the impacted areas that you need to focus on to have the wow effect. Why? Because when you had a monolithic application, the internals were somehow hidden from the client. So there was at least no clear and easy possibility to have a man-in-the-middle attack. But with microservice, everything is distributed. So in fact, you need to protect yourself from someone injecting a rogue service into your infrastructure. Well, this can happen. So why do I have to attack your front gateway, where there's authentication and everything is nice and heavily protected? I can just hire into your company, hack your Jenkins, Zul, or wherever you have, or GitLab, get an access there and push a service to production, a service that's not maintained by anyone. So think about that as well. We have a couple additional elements here, like authentication, key stores. Hey, you need to store your secrets somewhere, not hard code them. So this is also an important issue. So you need to have this figure it out how you're going to do it. It's much more complicated than with a monolithic application. So be aware of how many areas are affected. And we can split this into security layers with external gateway. So you protect your system from the outside. The API gateway will do the authentication. Even the cross-service communication will go through the API gateway. So we can have authentication authorization there. We can have service discovery so that only things that are in the service registry are published and can be used. And with this, we can also limit this API contract so that not everything that service offers is offered to the client or to other services. We also have to protect the event and queue elements. What does it mean? That when you emit some events, like we did with our order and fridge, these are results of some external interaction. So yes, you can verify the incoming request, but imagine that someone injects an event or a task into your pipeline, into your system. So is your service verifying that what's in the pipeline, in the queue, in the event pipeline, is it legit? And even if it's legit that this user can do this thing, is this order legit? Or maybe I've just injected something and I'm deleting all the data for a given user that never requested such a functionality. Think about that. This is also a very, very possible vector of attack. In the end, you also have to protect your data because we have services and these services have their data separately. These might be different databases, so they might require different protections. And this also means that there might be some level of encryption required. So do I encrypt the entire database or just a portion of it? Or do I encrypt for an entire system with a system key? Or maybe I will have a service key. Or maybe I will have some sort of user-based key because I don't want one user to have access to data of the other users, not only based on the authentication and authorization, but also based on the physical access. There's one thing with data that's very, very, very important. Don't have pre-production based on the dump of your user's data. It might be obvious for some, but remember, don't have pre-production based on the dump of your user data, because it only means that you have unencrypted data, or you're transferring the keys in the wrong place, or that you don't encrypt at all. So think about that. Many attacks happen because someone forgot this copied piece of data on some developer virtual machine, developer environment, and it's just sitting there, this couple gigabytes of user data that might surface in a couple of years. So think about that. We also need to focus on monitoring and audit. This is very important because everything is distributed. So when you had monolith, everything was logged into one pipeline and then sent to some other place. Now you have so many components and they all generate logs. And they not only generate logs, but they also generate events. And you need to have KPIs for that. The KPIs and monitoring systems are not just for you to have a nice dashboard or maybe receive a text message when something goes wrong. It's about having actions based on the scenarios. So in your blueprint, you also need to focus on security because you will have to have scenarios that start when there's a security threat. And perform a risk analysis. Why? Because in risk analysis, you can have all those layers secure, but also assume that everything can fail. So we might have a protected system when all those elements are green and operating at full capacity. But imagine that there is a hole in your external gateway. How your system will be impacted? Or maybe some guy just removed the encryption in the databases or broke it from the beginning. So what will happen? Will your system will be affected? How the other elements will compensate for this issue? So if you have elements that are very, very important, and they show you that there is a bus factor with this. So when this one element is broken or removed, then your entire system is open for the attack. Then you need to include that in your risk analysis. I'm not saying that you should address all of those elements with full capacity, but you need to focus on your business, and you know how your business will look like and how it will work and how much of this you need to implement. This relates not only to the monolithic, but also to the microservice architecture. But think about that. With microservices, it's very, very important that you do that. So now let's focus on the entity aspects, meaning because our application is a system-wide, we still have some entities inside. And how we do those entities, what we implement those entities, it can affect our entire application. So just to catch up with all the core components that we had, a couple advices on those elements that we really need. So as I mentioned, the API gateway to protect us from the outside and to control the business interface. It's a control of what we show outside. Template your services, but I don't mean template as a template that you just copy paste and you have another service, because this would mean cloning technology. Template approach. So have some process, have some development process, designing process to guide your new hires, new people in your team, how to do that correctly, so that most of your services are similar in terms of architecture approach. Also have the key store. Don't hard code secrets into your application. I know that you know that, but don't do that. So keep that in mind. You also need to have the deployment service, because deploying manually at midnight causes a lot of headache to everyone. And that's very important. So have this automated. Have this so that it's not prone to errors and it can be tested automatically before pushing to the production. So have all those scenarios thought out and played out into your system so that you are not afraid to merge on Friday. Keep that in mind. You need to have, obviously, some authentication, authorization system like OAuth. Think about that. Have the service discovery, which is also called service registry, so that you know what kind of services you have in your infrastructure. You need to be aware of that. It cannot be only a result of listing that you do on your system, but also it has to be a continuously updated database. You can also use that to store your interface description there. Also have the monitoring, as I mentioned, not just to have the dashboard, but also to have scenarios. So have the logs and events bound up in some system that you can view and you can analyze. And especially when you do have to audit. So what are the service patterns that I really like and that are really helpful? There's this one that I really love, and it's called circuit breaker. On the right side, it's not what you think it is. It's a diagram. So circuit breaker is a really, really cool feature. How it works? It counts the errors that you generate from your service. So you have incoming requests to a feature, and you have some errors that are happening for whatever reasons. When the errors reach a certain point, the feature, the service, it might be entire service or just a feature of a service, is disabled, immediately disabled. So it's not even processed. Client that wants to request this URL, wants to send a request or do something, they will be rejected immediately. So no capacity, no way of doing this. We are having problems. Go away, come back later. And the come back later is the clue. So you don't disable it entirely. You disable it for just a couple of minutes, some defined period of time, and then you switch it off, switch it on back again. So imagine that you don't have this feature and the order database is failing. It's getting really slow, overloaded, some infrastructure problem, something that we haven't predicted, or we invested enough, etc., etc. Or maybe the email service is failing and it's generating maximum timeouts in your system. So what will happen is that all the services that are requesting something from this service or all the actions on the service will bulk up because they will keep hanging, and you will have more and more requests that are taking more and more time to proceed before they are thrown away and the error is returned. This way, your resources will spike up and in the end, it might be that your infrastructure will blow up. So with the circuit breaker enabled, your infrastructure will be, your feature will be disabled. So I'm not saying that it will fix your problem. The clients will still get the error, but at least your infrastructure will not blow up and it will oscillate on half of the capacity. So it might be that this problem is just temporary. The database is just failing for a couple of minutes every day. So I'm not saying it's nothing to worry about, but it will not cause the overload. And if you have some shared clusters, shared resources, like a single Kubernetes, then it means that it will not consume all of your resources, and the features that are not even related to the order or to the email can still function. So you will get half of the capacity, but it will work and it can self-heal. So the circuit breaker is part of self-healing. So it will not do and fix everything for you, but it will save your infrastructure. There are a couple more cool patterns that you can use. Some of them you've already seen in the design. They are called event patterns, and you can use events for certain things, like we've seen, the order communicates something to the fridge, so that the fridge doesn't have to wait for the request to complete, and the service just emits something, and this is a cool feature because the order doesn't know who's listening, and it doesn't care. We have a contract on the event, not on the interaction. So this is really cool because you can shout at the event pipeline and just do your business. You don't have to get a response that someone got this message. You can also use this capability to implement so-called event sourcing based on the command query separation. You can have a client. Imagine that a client wants to change something on the resource, and instead of just doing the database change directly, it will emit an event. And this event will go into pipeline and come back even to the same service, probably to the same service, just different instant, different process. And this process will do the change in the database. So you separate this, and what are the benefits? Let's have our simple diagram based on the simple application. So when when the order emits an event, the fridge will get it and do some business operations based on that event. And if a fridge wants to change this resource state, it will emit an event as well. And this event will come back to the fridge and it will change its database. So there are many benefits out of that. One, you do the separation. The other is that state changes are recorded in your streaming system so that you can roll back if you want to, and you have all the history. So things like history features or memento pattern, they are just for free, well, to some limited extent, and the retention period, but you can have that. And all those database changes, you don't have to generate separate, like for those that know Django, you don't have to generate separate signals that will trigger some form of archivization. You can just read the events in a different service, a service that's responsible having the history. So all those elements are for free. And it doesn't mean that you have an event-based system. It just means that for some business operations, you use the events to facilitate the business in a nice, resilient way. It's a bit useful when it comes to monitoring logs, so you don't have to create separate logs stating that you did something. You just focus on the event, so you can have the monitoring listening to those events as well and react. And this means that monitoring is not only a matter of security and stability, but also what's more important is the matter of business. So based on this, you can implement billing system, because you know how the states are being changed in your infrastructure. So you don't have to have a separate service with a separate interface, strict interface that is being called when something is being changed. You can just base that on events and possible rollbacks. So it's decoupled and it's free for you to change the business logic without much influence. I don't know how many of you work with great big infrastructures and billings, but I've heard and I've seen that billing is always the problem. So it always changes the most often, and it's the core of the business to get the money for what you're doing. So it's very important that you implement it in a way that any interface changes will not affect the entirety of system. So it complicates a bit the transactions. So if you want to have transactional data and consistency, then you need to implement transactions manager. But for those that, for example, use Apache Kafka, there's a transaction manager implemented into that as well. So from a certain version, so you can use that and you can implement this to have a bit of transactional consistency for your events. Now, my most favorite, and something that many people know for those that use Python, Celery tasks. This is Saga pattern. So it resolves about a couple simple use cases, which mean that we want to do something like this transactional changes of the state in a certain order. So it means that when we want to change in a way that we have consistency or we have a couple endings on the resource based on what happens in the database, you can do this with Saga pattern. So you can ensure that the consistent fallback, consistent change is being done with the Saga. You don't have to use events. So this is alternative. You can also use the asynchronous tasks, so that when you have a request incoming, you get a task instead of the outcome. So you can, so the service can perform changes and perform your task in a matter that it sees fits, based on the performance, capability, wherever, and it can roll back or it can pause. So the execution can be delayed, but you still have the instance of the task that you can monitor. It can also be used to implement high-level scenarios, which means that there's this certain pattern that I didn't want to confuse you with too much. It's called aggregator component, which means that you have this bigger component, bigger service that provides, for example, some sort of backend assisted rendering of a front end. So some business features that could be developed in front end are developed in the backend, so that it's done in a different way. So like, for example, you have hundreds of infrastructures that you need to contact. So instead of having this on the front end, you can have this in the backend as asynchronous tasks, and this component will talk to all of those elements for you. So this is how it looks like in our simple application. We have a queue, so when we accept the order food, we return a task ID with a reference to it. You get a task which is put into the queue, and there's this separate task worker. So it's still deployed with the order service. It's not a separate service or domain. It's just a component inside that service. So it has to be deployed together because the tasks are the code, and they should be versioned as well. So you need to have that, but you can decouple the processing on the request interface, this interface that you accept requests on, to this background. So you can scale those separately. You might have this one process that accepts the services and hundreds of task workers. And it doesn't matter because you can scale them separately. So you can also adjust that dynamically based on the amount of orders. So this is the deployment scenario that I talked about. So you have certain steps. You send the email order summary, and then we get an email. So beware of this pattern because it's very useful, but it's very easy to create a monstrous task that will just do everything. Like it will have a lot of chains, a lot of smaller stories inside, correlation, logic, and it will just be everything in one place and everything in one task. Have a look at that. If you design this in such a way and implement such a way, it might mean that you have one domain that's just too big, and maybe some pieces of this task should be in a separate domain or separate subdomain, because it's not only about having one box as a domain. You might have different services that can be subdomains. So this can be decomposed. To summarize, what I want you to remember from this great presentation, I hope, is that the pyramid of healthy microservice. So contrary to what some might think, We don't focus on the technology first. We focus on the design and the interface. So design your interface and have your business defined in a form of interface. Then invest most of your time in this, and then reuse the patterns that you have on architectural level to meet your requirements. Your business requirements, not your technology requirements, but to meet what you want to do and why you want to do it. Design, reuse, and then at the very top, you need to choose technology and the team to meet your business goals. And that's the healthy pyramid that I propose. And this is what I would like you to remember from this presentation. Design the interface. Okay. And thank you.
Thank you. So any questions are most welcome, please. Feel free to join us here downstairs. Pyramids, food, fridges, orders, anything you'd like to ask about. Floor is yours. Would you like to join us here, please? Thank you. And then anybody, if you're interested, you can be next.
Hello. I will provide some scenario and then ask question.
All right.
So let's imagine the situation. We have a huge amount of invoices.
A bit closer.
Huge amount of invoices, huge amount of customers, and among many other tasks we want to do, one of them is like find all the invoices from all customers which are from this particular city. So doing this old way, we have database, we join tables, and we can do this pretty effectively. And now we have microservices. We have service for customers, service for invoices, and we don't want to have extra microservice to do this extra task. On the other hand, we don't want to send such amount of data between microservices.
Yeah, I see that.
And here's the question: what to do?
Yeah, what to do. So the question is that they had a monolith which contained data about invoices and orders, clients. I'm sorry. So about invoices and clients, and they wanted to filter out the two pools of data. So they split this into microservices. So they have resources for the invoices, resources for the clients or orders. It doesn't matter at this point. They have these two services and they have interface. So I assume that very top they have some sort of business representation of the connections, and they want to filter that out. And do they need a separate component? So it might be that, and how to do it efficiently, because when you separate big pools of data, you need to remember that you decouple the interfaces, but you also split them on performance level. So it means that when you correlated something as a big model in your database, it was quick and easy to fetch all the data and correlate this data on the database level. But when you split that into two elements, then it's get more and more complicated because you have additional protocols, like you have to transfer all the data through the JSON. So what I would advise to do is to define and have a look at your domains, whether this can be one domain, whether this can be connected into one, not monolith, but maybe a domain that it will result with business implementation in one of the services. So what are the relations between the data? What can you filter at? What can you cache? And maybe it will turn out that you will have some sort of aggregator that will fetch the data and fetch the references and do nice filtering on that. Or maybe you'll have state changes to speed this up. So it's not so easy to answer whether you should have implementation in this service or the other, or have something else. Because have you seen on the slide, you might have different approaches, and what you need to do to decide is to have a closer look at your elements. But it's a nice problem that you have, and if you want, we can talk outside and discuss this in more detail, because it's really about what are the invoices relations to the clients and where you would like to have the business of correlating the data. More question?
Yes, I have a question. Question about the interfaces between the services that you have, and whether mixing the styles of interfaces and having is it better to stick to one type of interface? For example, all services are triggered via request and response communication, or maybe have all the services respond only to events that are happening in the system, so like this pure event sourcing or pure synchronous communication, or maybe it's fine to mix and match the way the different services are triggered to do their work, some of them being triggered by a specific request to them, some of them being triggered by just an event that happens somewhere in the system.
Okay, so to simplify, the question is whether we should stick to one type of interface, whether we should have not only type, but I assume that it can also be a type, but in a way it operates. So whether we have this order, this request incoming, that request is being done, and then the data of that's a result is being returned, or we have just tasks or just events, and the answer is do a mixing. And that's what I mentioned also during the presentation. It's not either this or that. You have to analyze your business, whether this getting information because it can be cached. Maybe it's better to have request and request response, and maybe for some other task like generating some sort of a report, it's better to have this as a task that's asynchronous. So a task is returned and you can monitor the operation. My general rule is something I included in the presentation as well. Anything that takes more than 1 second to process at this current moment should be asynchronous task. So this is my advice, that if it takes a while, have it as an asynchronous task to gather the data. So it would also be the case for the invoices and customers and orders, because you would have to have this correlation of data happening in the background. You cannot let your customers hang out on the connection. So it's a mixing. So you need to analyze each of the features and decide whether you want to have this way or another way. Do not have either black or white.
And we've got several minutes for one more question, please.
This will be probably a fast one, because you partially answered this my question a second ago. But imagining a system consisting many services, and they are communicating each other, there's a need to make to implement the communication between the services itself. During the presentation, you mentioned some event managers, if I remember correctly.
Transaction managers as well, but yeah. So okay.
Because my question is, having a mix of different ways of communications may lead to the situation that each of our microservice needs to implement several ways of only communicating to other services, like communicating with one service through the REST API, with other through the RPC calls or something like this. It leads to chaos. So is there a way to avoid it?
Well, there is a way to avoid it on architectural level. So the question is whether it's also about the type that I mentioned. So whether you want to have just REST interface, REST APIs, or WebSocket APIs, or so popular recently gRPC based on protobuf. So or events like event bus like Kafka, or maybe Celery, but that's not true service communication. But so the question is how to avoid having 4 types of interface. So 4 types of client implementation in a given service, because this service has to communicate with so many. So my advice is yes, it can be avoided, but it's a matter of having your business analyzed. So whether do I need to have so many interfaces, what they are bringing to my system, and not only do I really need to communicate these services directly. Maybe I can fetch this data in a way, maybe I can react to this data. So that kind of situations is usually a case where you had different teams liking different technologies. So at this very top, where you discuss how your business, how your interface needs to be represented, this is the place where you decide. So if you start with the technology, then you might lock on one team on gRPC, the other on the rest. So I'm not saying that it will be perfect, but when you analyze from the business perspective, from the interface perspective, then it can be avoided. But yeah.
Thank you. Thank you very much for all the questions. And this was Nokia's own Remigiusz Michułka. Thank you very much, and let me just announce you the last break of the day. It's going to last half an hour, but please do show up at 5 for 3 lighting talks, so this will be the last session of the day. So again, half an hour break, and then at 5, 3 lighting talks in a row. Thank you. So thanks for coming back in such large numbers for our last round. And this round is 3 lighting talks. So we've got an hour, and each of these talks will last for about 15 minutes. Just a very brief then session of Q&As. A quick reminder, please don't forget that we've got a middle party afterwards today, and it will be held in this pub called Szklarnia. It's a cocktail bar. Actually, it's not far away from here, within a walking distance, so feel free to join any code divers there at 7. And as you may remember, earlier today we had a fragrant talk on smells, and this time round we're going to have a fruity talk, and it will be connected with bananas, and it will be delivered by Nokia's own Arletta Jasonek. She is quality assurance expert at Nokia. She loves to understand and help users. She also loves sharing knowledge, and in private life she's a wife, a mum and a bookworm, not always in that order. And the very interesting about Arletta is that she was born in times of shortages in Poland. So these were the times when bananas were not very easy to get. And actually Arletta had her first banana when she was 12, and she says that at that time she thought it was a kind of potato. But the memory of that event stayed with her, and she's going to use it today for her talk that's called How Bananas Could Save Your Project Understanding UX. And just a quick reminder, this Arletta used to be co-organizer of Code Dive, and today it is her first time as a speaker. So let's give her an especially warm welcome. Arletta Jasonek.
Welcome everybody. My name is Arletta Jasonek. I work for Nokia. In next 15 minutes, together, we will try to understand the main concept of user experience. In case of any questions, there will be a time for them, I hope, after the talk, and banana, one question, right? There is a lot of fruits in the product alley, and there is a lot of software on the market. No matter if we are a user or a producer, we are looking for that perfect one. User experience makes that perfection, makes that difference. If any one type of fruit was designed perfectly by nature, it would have to be the banana. Banana tastes good and is good for you. And it also has some additional factors which are added to the entire experience of snacking. Most of us will use our eyes to observe banana long before we smell, touch, or taste it. Banana are designed to be obvious. They have a built-in accurate visual cue. We don't have to waste time questioning if they are ready or not. They're just designed to be obvious. They are green before they're ready, and they are brown once they pass their prime. But that bright yellow peel means it is at its best flavor and ready to eat. Not only the peel of the banana shows if it's ready to eat, but it also protects the fruit. Bananas are mobile. We don't need special container or lunchbox to grab our banana and just put it to our bag or purse and eat when and whenever we like. Eating banana is a seamless experience because there is nothing in the way. No hidden seeds, no pit in the middle, no core to work around. Biting into banana is a comfortable and effortless experience. Bananas are grown worldwide all year long, and they are quite inexpensive, making them available just about everyone. Bananas also contain vitamin B6, which helps produce serotonin, And serotonin is responsible for keeping us in a good mood. So we can say that bananas literally can make you happy. Other fruits have their advantages, but when it comes to the entire experience, they all have some faults, making them not as quite nice as the banana. Obviously, there are some fruits that are much prettier than banana, but being aesthetically pleasing is just one kind design, one feature. There are fruits with better nutritional values, but if the most important fact is nutrition, we just could take a vitamin. And there are fruits that taste better, not like a potato, that taste better than bananas. But that's, again, just one kind of design. UX design is about the entire experience, from start to finish consuming a product. Some UX designers work offline, but the majority work with digital products. The human-computer interaction has dramatically improved over the last 10, 5, even last year. And in large part, this is because of UX designer. If you navigate through an app or website with a smile on your face, you can be sure there is probably UX designer out there who created the interface specifically for that reaction. The job of UX designer requires understanding capabilities of the product and how the user will naturally act with technology, and connects the two with strategic design thinking. Unwanted pop-up when you are already signed up, that's a pity. But when the pop-up has the information you need in the exact moment you need it, that's banana UX. If you assume a very broad understanding of user experience as user experience covering all aspects of interaction with company, its services and product, then UX in IT companies is not only related to the work of UX designers, business analysts, front-end programmers, but also marketing, customer service, sales, and help desk employees. You may be surprised with such approach of UX, but aren't the employees of the above departments participating in the process of analyzing requirements, defining business needs, creating prototyping? Is it not the case that every company with its product services is evaluated by the customer not only for their product, but also for quality of customer service, readability and availability of the offer, and quality of post-warranty service? However, we must not forget that in addition to beautiful design, latest technology, new number of functionalities, the most important is the fact that the user problem is solved, which often becomes a #1 design problem. Because what is another vocabulary application with system of reminders, prices, repetitions, if it's unable to teach us chosen language, hence solve our main problem? What is the latest model of smartphone full of functionalities with computing capabilities exceeding Apollo's first spacecraft if some user cannot easily handle it and solve their main problem, which is a need of remote conversation? And that's a shame, since Alexander Bell patented the solution in 1876. What finally is a system supporting work in production, logistic company, office, hospital, if instead of improving processes previously documented in a traditional way, it duplicates them. Instead of speeding up the job, slows it down. In each of the above examples, the user is a victim. But not only the user, the injured party is supplier, producer, in example, our company. Because we lost a satisfied customer, satisfied user, we lost an employee who did his work efficiently, but before. The reason is lack knowledge, lack awareness, lack abilities to use UX techniques. But not every organization employs such people as UX designers. Not every team has such a person available. So, what can we do? I believe user experience should meet everyone who has influence, who has impact in product, and anyone who cares about the business success of the product. Wake up, guys. The cure is in you. Any developers among the audience? Come on, guys, raise your hands, please. Okay, many, I would say. This is called Dive Conference, right? A lot of developers. Developers, because you often interpret in your own way requirements described by product owner or business analyst, which is good. However, not having awareness and at least basic knowledge of UX, you create an ideal, readable, and full of functionality application, but useful and easy to use only to you, not for the user. An example, a child, senior, an average person using computer and tablet just to handling emails, browsing the net. Have you seen Silicon Valley, the TV series? Anyone? Please raise a hand. Yes, there are a couple of you. So you know what I mean, right? We are now getting to the end of the talk, but there is still one thing I would like to ask you for. No matter if you are developer, product owner, tester, manager, or help desk guy, like I am, just please hold on for the moment and think. Is the product you're working on just next regular product among any other similar on the market? Or if your product is banana UX product, which I wish to all of you. Thank you.
Do it properly, come on. Thank you so much, and we were serious about it, so one question, one banana, and if you like one, the floor is yours here downstairs, please. You can share your example like you created something that was really bad for UX.
I have a question, if I may. So, do you mean by banana UX that the actual user feedback, like, you know, do you know the concept of banana programming, where your product matures at the client? So, you know, you ship the product and then you find the bugs because your clients report them to you. So, did you mean banana UX, like ship the product and let your client tell you what are the UX, you know, bad habits you've had? That would be the first one, but the actual serious one is, do you find a place in quality assurance in QA themselves to give the feedback about the user experience, and without like a dedicated UX person, or whether is their role? How do you feel there is that? Because I know that at my company, often the first line of user experience feedbacks is the QA, and sometimes it's devalued because they should be testing functionality. At least sometimes that's the feedback to them about their comments. So how do you feel about that? Do you have any comment?
I'm in this happy situation that in my team, in my project, we work strictly with specification guys, and when specification guy described his requirements, and me or someone from my team understand it in our own way, we just have the time and space and place to just grab that person and talk with them about it, right? And you were asking if as a QA I have such place to so the answer is yes, at least in my project. I work for Nokia and we are hiring, so.
Thank you very much. Your question was incredibly long, so you're getting 2, please. Any more banana lovers? Any more questions?
Is there anyone who have never eaten a banana? Okay. You know, my kids ate banana when they were 2 months?
2 months,
No.
yeah.
Yeah, something like that.
So they've got 12 years on you. Again, thank you very much. Arletta Jasonek.
Thank you.
So don't go away, we're not having a break, and we will continue as advertised, and this time we will be listening to Łukasz Kucharski. He started programming in his teens. He's gone down enough wrong paths to recognize them and then avoid them. His programming credo is to write such code that when you're fired, then your project is easily taken over. However, the logical thinking is that if you are such an employee, then you are not very likely to get fired. And he likes solid principles, spiced up with Yagni, but his favorite software engineering rule is there are no absolutes, always be reasonable. And at work, on top of working, he likes to have all those discussions which end up in various bets, and those bets are resolved by Godbolt's compiler Explorer. And Łukasz has a case study for us called When Warnings Become Errors, a case study of latent bugs discovered by modernizing toolchain. So the stage is yours. Let's warmly welcome Łukasz Kucharski.
Okay. Okay, I think I'm online. Thank you very much for the introduction. As the first word, I would like to reiterate what I've heard on the other talk. All hail Matt Godbolt for his work. I think he's the most prevalent here. Okay, so I know that Rafał didn't mention one thing that this talk is about because it's kind of a taboo, and it's we don't like it as we don't like undefined behavior. It's there and we always laugh about it, and it's business. So I want to have a brief moment and talk about how to talk to business to let them do you do fun stuff and modernize your toolchain and compiler to get all the best and newest shiny tools. So yeah, here's a bit about me. If you want to contact me, you can use łukaszkucharski@mentor.com, and if they fire me, you can use yayamiomat@gmail.com. It's my personal email. So here is a brief introduction because it's a case study. So a few words about our code base. It's 5 to 10 million lines long. That's a rough estimate. It's not so easy to count when you have symbolic links in the build tree. It's been developed since 1995, and that makes it lots of legacy code. And also, those were the first commits, so the actual code is a bit older. We are in the process of transitioning from GCC 4.94, and we're using Switch, STD, C++, 1Y, because C++ 14 wasn't fully developed back then. And we've had to do lots and lots of patching and relaxing compiler errors to warnings just to make GCC 9 accepted in the process of transitioning. This is the courtesy of Grzegorz Roszak, who couldn't make it here as an attendee, but we say hi. And to gather the data about the issues, I have hacked run clang tidy to save the compilation information into an SQLite database for the further processing, because there was lots and lots of them. So what I'm going to talk about is with no checks enabled at all. It just had modernize equals defaults because that was our use case, and it still reported almost 2,000 issues that prevented Clang from compiling the code, while GCC we used perfectly accepted it. I also, for the fun of it, ran with all the checks that Clang tidy supports, and there were 3 million issues in our code base, but 2 million of them were magic numbers. So that's to say that not every issue is a fatal one and critical one, but we'll get that there are quite a lot funky ones to play with. So this is the business slide. I'm really sorry that it's wordy, but it's a business slide, so I hope it can I can sleep with it. So the important here is that the cost of fixing a bug increases exponentially depending on the phase that it was found. And different studies that I found give different estimates. So here on the graph, you can see that it rises about 6 times or 30 times from 1, depending on how you understand requirements and architecture. And IBM report says that a bug found at the client side costs 100 times more to fix than the one identified at some maintenance stage, such as compilation or static check. So if that bug costs developers time in money $100, because I don't know how much your salary is, but let's say that on average 4 hours of fixing is $100, then that found out at client makes it $10,000. So why that happens is because at each stage, especially in enterprise software, different layers of the procedural overhead come in. So when you're a developer and you find a bug, you just fix it, and hopefully no one notices, no one laughs at you. If it's a code review, then you just go to your friend and say, hey, why are you bit shifting one right and not left? Okay? And if it's QA, then they have to file official QA bug into the ticket system. It needs to get fixed, it needs to get tested again. You understand the thing. If it's an application engineer, it's a buffer between the product and the client. Those reports are even more treated seriously. And when you get to the post-release, so a latent bug at the client code, you can imagine how much paperwork and procedures and layers and people are involved in fixing that. So that's why it happens. And managers often would let you do this work, but they cannot just let someone work for a month or a quarter on something unproductive like modernizing toolbase. It provides no new functionality, so no new value for them. But if you take $1,000 for fixing a bug at the client or manifesting a bug at the client, and you scale that against the code base, like in our example, there were 2,000 hotspots, And I expect that 1/3 to 1/2 are actual places that should be addressed. Not everything is fatal, but they are not perfect, and certainly there are bugs that are just waiting for good conditions to happen to blow up. So if you scale that by $10,000, suddenly your manager can speak to their manager. Like, there is potentially a lot of money, so maybe we should let this guy do the work and let him get his shiny tools so he simply doesn't commit bugs that are easily preventable with those tools. As a bonus, his friends also won't commit those bugs because everyone will be protected through the tooling. And we've had already 2 great talks today, especially the first 2 about the code smells and about the undefined behavior. So I don't have to underline the importance of that to you. So with the remaining time, I hope I will bump up the what the funk factor and get some laughs about what actual bugs were found in our code base. So first, what we got there, logical node is applied only to the left side. So we've actually had those codes, those are anonymized, and they're latent bugs, so it's not that our tool is blowing up all the time. It's just in some place that's not so used. So someone had the idea of putting exclamation mark at the left side. And what this does is it takes the integer value that's result of the function call. It compresses them to 1 or 0 because it's an implicit cast to bool for the exclamation mark. It applies the logical not. And then for the comparison, it gets promoted to an integer. And then it gets compared to the right side. So first 2 examples are tautologies, and compiler tells you that this doesn't make sense, so you probably should check it. I don't think this code works as intended. The vector size, I don't have time to go into the detail how this logic works. It was very funny to debug and understand it, because it works somehow, and compiler cannot tell whether it's right or wrong. And out of 16 cases, we've had 10 bugs. So, and 5 of those only were tautologies, so the obvious places that are some kind of mistake. And 6 places, sorry, that was a Freudian mistake. I have a Stockholm syndrome with this stuff. 6 places were actually fine, because if on the right side you will place a 0, then the logic works the same. So the places that were fine were comparing to an enum, like OK or some error code, which was 0, and some of them were comparing to a character 0, which happens to be like /0, the null termination character, which happens to be 0. Sorry. Another one. The result of comparison of some big constant and unsigned is always false. So this is similar. This is not super important, but it's obviously wrong. So this comes from all 32-bit codes. There was one talk mentioning it. I think Björn also in his talk thought that when he saw this really big value, he thought it's npos, and it wasn't. But here it is. And found is actually defined as unsigned is actually 32 bits. So when you assign the rfind to it, it will get implicitly converted. And then found cannot be ever as big as max int 64. So I guess that's almost auto says hi. But the code was actually too old. It was just that this warning was disregarded. And I guess that other places in this if prevented him from actually surfacing. Maybe not a big deal, but this is exactly the same error. But here, the message was that the constant 14 compared to a bool is always false. So, okay. Why 14? What's this number? So the DB version 14 is number 14. So how it gets compared to a Boolean? So if you call DB API get version and DB version, how it works is that it stores the value of the DB version into the variable, but it itself returns whether the call succeeded or not. So I hope that nobody uses version more than 14, because then it works the same. Or that the 3 dots were not really that important in there. Okay, this one is interesting. Unused comparison. So some of the unused comparisons were just to shut down the compiler warnings, but this one was really interesting. So what this code does is iterate over 2 containers simultaneously. There is a container with values and container with related values. Cannot say it any better, sorry. But the interesting thing happens on the second line of these 4. So it works pretty normally. It sets up the iterators, and it increases those iterators on each step. But I suppose, I haven't asked the original author, that it should stop whether either of those containers ends. So we have exhausted it. But for some reason, they used comma. And what does comma do is ignore the result. So this is not checked. There should be a logical end in there. And I hope the sizes always match. Okay. This one is pretty funky, I would say. So this is just a parenthesis or operator precedence. That's why on the Jason Turner's talk, I've actually shouted out a wrong answer to his question about some return value. So the operator precedence there was okay, but I still would put some parentheses in there. And here we have some examples where this would happen. So the table size, I presume it should be all the f's, so 2 to the power of 14th minus 1, but actually it's 1 to the power of 13, so it's roughly half the size. I hope the table size is not needed to be actually that big, but I don't know. But our jam is that a ternary operator has a lower precedence than a plus. So I presume that the author meant, and this is original formatting with all the spaces, so that's why it confused me in the first place, is to get the number of bits set. So if you check 2 bits, then you probably would expect a value between 0 and 2. But how it works, it checks bit number 0, whether it's true or false, and if it's set, then we return 1, and if not, then we add 0, which is completely redundant here, and we check the next bit. I don't think that's what author meant. There was cases why I'm talking about most vexing parse, because every developer, when there is a problem with the most vexing parse, would probably give their little finger that it's a bug. We've had 12 cases, but none of them were errors. Some of them were generated by Yak and Bison, but we've had errors when the mutex was defined like that. And I won't go into details again because I don't have time and I need to wrap up, but this is a pretty nasty bug to debug, and when it manifests, because it deals with parallel codes, you should correct it. Okay, this one was tricky. If I were to have time, this is a bonus, so I won't talk about it. It's in the slide for you as a homework. This is a summary. Just spend some time to run the static checker, get it from the manager, just a week to do some hacking, pick interesting latent screw-ups. So the manager, say you have the dozen against the million lines code base, hundreds or thousands. Don't lie, base it on the actual data, and show them the cost studies. This really talks to the business people because it's money that can blow up. It should be really easier to get the time to get your new shiny tools. Okay, those are the references. Again, thanks Godbolt, Clang, and GCC, which are not mentioned here. And thanks for your attention.
Thank you very much. Thank you. Thank you, Łukasz. Any questions? If you'd like to come down here and ask a question, as a reward, you can have a bet with Łukasz and then lose it. Thank you for being so brave.
Clang has an option when you got those errors to auto-fix them. Have you tried it?
Yeah, so we actually, the use case was to use the fixer for modernize equals defaults, but we've had a problem with even running it because it reported issues for the compilation. So the run clang tidy didn't work properly, and because of the symlinks, we couldn't really so easily apply it. So we need to hack the patch processing as well to work with symlinking.
And finally, it worked and fixed all those errors after it compiles, maybe, or how many did it fix?
No. So it found about 5,000 places in our code base for that, but and it fixed it all, but in an incorrect manner. Some of them. So it actually applied the patch a few times if there were 2 valid paths to achieve the file. So that's why we couldn't actually use it.
Okay.
Thank you. Any more questions, please? All right, then. If not, let's thank again Łukasz Kucharski.
Thank you very much.
And wrapping up today, so this is the last talk of the day, and the last lighting talk at the same time will be delivered by Mateusz Brzeszcz, software developer at Adaptive Vision. His whole career he has been revolving around image processing, starting in the dark ages, that is before deep learning revolution. And Mateusz has always been focused on real-time algorithms. He is an avid programming competitions contestant, or he was in the past, and also co-creator of the Deadline 24 marathon. And after listening to some of the Code Dive talks in the past from the viewer seat, he decided he would like to try a new perspective, the perspective of a speaker, and also he thinks that our Code Dive t-shirts are really, really cool. So he will be delivering his faster than memcpy talk. Mateusz Brzeszcz.
Okay, is it on? Is it on? Okay, it's on. So, good evening, everyone. Today I have prepared a few cases distilled from the real-life code. So, let's dive in. The first thing, the importance of measuring. So there is no fast code without profiling, as there is no correct code without testing. And the first thing that we need to do when profiling code, we need to establish some baseline. So let's be ambitious and let's get a memcpy here. Oh, okay, it doesn't work very well. So our baseline for today will be a simple memory copy. And as you may know, there is no faster operation, contrary to what the title of the talk said, but let's see. So we copy some memory on some system. We have a 1 millisecond of time spent on this function, and then we can do some processing. Let's get an ambitious function that adds 3 to every input byte. So we test and we compare to baseline, and we have just broken the law of no thing can be faster than memcpy. We have a function that is 5 times faster. So something is clearly wrong, so let's check it. Quick disassembly. I'm not perfect in reading this assembly on the fly, but the one thing that we can see that this algorithm, so-called algorithm, is vectorized nicely, and this copy function is just a tight loop. Let's see what happened. This was tested on the Microsoft Visual Compiler. It has a nice reporting feature, so it reports what gets vectorized and what's not. So we are told that loop not vectorized due to some reason. And when we check the documentation, that reason is that this code is too simple, so there will be no vectorization, and instead we expect for memcpy to be emitted, except that no memcpy was emitted here in this code. What's the result? The result is that the algorithm, so-called algorithm, was okay, and the benchmark baseline was flawed. So if we are measuring high-performance code, it's important to have some reference point. And what's more important is that to this reference point to be correct. Let's say you are given a task of accelerating some code, and you get this code, you work on it, you have I don't know, a 50% increase in speed, but you hadn't noticed that you were testing this on the debug configuration, and of course everything goes down the drain because this baseline was not okay. So if you push this code to production, it may be faster, it may be slower, but the result is irrelevant. And by the way, the other compiler does it properly. So yeah, that's probably a compiler bug. It's not important here. What is important that you need to check everything, even the baselines. Okay, the next case, vectorization. It's a funny one. Let's have another thing. We have algorithm that processes images. So we go row by row, and then we process a row. We multiply by 2 every byte on the input. So the standard loop vectorization method works like that. We process the buffer by using vector instructions, and if we are left with something at the end, a few bytes, then we process scarcely because the vector instruction cannot fit in there. And let's see what we have here. This is some intrinsics, not really important. It's multiplication by 2 is implemented by adding the same value twice. Anyway, what's the result? The result, the first thing is that the compiler optimizes, the compiler vectorizes this code slightly better than we did. So it's good to rely on compiler optimization, not to write everything by hand, usually. But one thing, we have a huge performance penalty associated with processing with the scalar instructions. So if we have input divisible by vector length, everything is okay. So what can we do about it? We can do a little hack. So we don't process the input by scalar instructions, even if we are left with some reminder. We just go back a little bit, so that this last vector instruction ends where the buffer ends. And let's test that. Okay, we have a very nice flat chart of the processing time versus width. So yeah, this nail type, but what? Okay, another thing. I have tested that in real life-ish example. An image erosion is essentially taking a minimum of neighborhood of a pixel. Yeah, this is a vertical erosion, so only in vertical dimension. And if we have a boundary case, when the width is near the multiple of vector length, we can even have a 2 times speed up. Some remarks. This is not very widely used optimization, I believe, because if possible, we should treat whole image as a buffer, as a continuous buffer. So we then just fire the processing on such a buffer, and the penalty can be neglected. It will be a few instructions on the whole image, and if possible, for small buffers, when this penalty is more visible, we can just pad the memory and use, and in both these cases, we can use then the compiler-generated code, the compiler, and trust the compiler vectorizer. But one use case that's interesting, if you are writing to a part of a larger image, so you have a larger image written as a call major row major form, and you need to write into a specific part. So you cannot pad buffer, you don't have a continuous memory. And another thing, it doesn't work for accumulators for obvious reasons. We have redundant processing. Okay, and the third one, Kucharski as a false rank. I believe I will explain what a false rank is in a simple terms. So let's say you have 2 memory locations when you have, let's say, 2 variables, and you access these variables from 2 threads. Everything is fine as long as they don't land in a single cache line, because most processors synchronize on a cache line. So if they will land in a single cache line, then every write of variable A will will propagate through all the processor cores. Why so? We have a algorithm, a simple algorithm that produces a list of bright pixels that exceed some threshold. The important part is circled there. So we have the list is a simple std vector. So and as before, we process the image row by row, and then we process row separately. And then okay, a simple acceleration. So we divide the input image for a few regions, and then process these regions in parallel. And at the end, we just merge these resultant vectors. Okay, so yeah, this is we fire that, and we see that the parallel code is slower than a single-threaded one for some given data. And why that happened? We have a separate vectors for every thread, so and every vector has its own memory storage that isn't shared for sure. And we have pre-allocated memory, there are no allocations. And what happened? Let's see how does the array of vectors look like. So the data may be separate, but we have false sharing on the metadata. So every time we push back to a vector, we need to update the my last field here. And if this code is run on 4 threads, then clearly there must be at least 3 threads that are contesting on a single cache line. And what's the solution? The solution is very simple. We just need to pad this vector. We just aligned this to reside for every vector and its metadata to reside in a separate cache line. And yeah, and if we run that, we have expected speed up. We don't have a 4, of course, because we have some operations and so on. But yeah, the speed up is as to be expected. So that's all that I have. If there are no questions.
Thank you very much. Any questions, please? Oh yeah, why not? An applause. Thank you. And now, any questions, please? One over there, I believe.
Hi, I wanted to ask about the plot. It was somewhere mid-presentation. It was like a saw plot.
Okay.
Yeah, could you explain? Okay, that one is good. So why do we have this drop at every multiply of 32 and then suddenly rise again? Why the pattern repeats?
What's the question about which color again? Which one?
Anything aside from orange. So for the blue one, for instance.
Okay.
So why do we have this sudden drops in processing time for a certain amount and then rise again and drop again?
Okay, so this is the reason. So if we have a vector instruction, it actually takes the same amount of time on a scalar instruction. Usually, it's not always true, but usually it's true. And we can, in one loop iteration, process a lot of stuff. It takes some time. Again, lots of stuff. It takes some time. But every element at the end needs another loop iteration, and it takes a comparable time that to processing the whole vector. So this is the main reason. Because if you have back to chart, okay. Here, let's say we are at 32. We process the whole buffer in a one vector instruction. Actually, it's two, but never mind. It's a technical issue. But yeah, we process this as a whole. And then if we lengthen that buffer, for example, let's go to 63. So we have one instruction that, one loop iteration that processes 32 elements, and 31 loop iterations that processes one element at a time. So this is why it's slow. And why it drops at the 64, it drops right to the bottom, because it's just two loop iterations and doing the vector instructions here.
Okay, so basically the thing is that just the data is so small that the effect of vectorizing even a few elements is just rows of magnitude better than iterating over it. So if we like plotted it for, I don't know, like for instance 1,000 or 10,000 pixels, the plot would continue to have this pattern, but actually after the time it would be dominated by SIMD, right?
Yes, exactly. Okay. This penalty is constant on the vector length. So
yeah, okay.
And
the vectorization part will be growing.
Yeah, exactly.
Okay.
And yeah, this is what I've said here in the remarks. If you have an option of processing the whole image in a one run, it's perfect, because this penalty vanishes. But it's not always true. Sometimes you have small buffers that you cannot pad. And this example that I've worked with is when you have an image and you cannot access these pixels behind some, let's say a box. You have an image, and you need to do something in a center box. This is a lot of buffers that are not always divisible by vector length.
Yep. Okay, thank you.
Thanks very much. Any more questions, please? Yeah, one over here.
Yeah, it's a follow-up. So if I understood, so the rising part was because there was like a tail for processing that was processing in a linear iterative manner. So if I'm understanding this correctly, and this is true, then why couldn't the compiler or processor execute it another using SIMD version, but with some trash data and discard the result? So why did it have to switch to the iteration back again?
First of all, the compiler doesn't know if it can access the data. Let's say you have a function and you pass the buffer of 40 bytes, and then you have memory addresses that are protected by a kernel. If you access them, there is a segmentation fault. So if you can pad the memory, that's perfect. Then you can do whatever you want.
All right, let's thank our last speaker, Mateusz Brzeszcz. So thanks very much for coming. This is it for today. Don't forget that there's a middle party. Again, it's called Szklarnia, and it's just a few blocks away from here within a walking distance. It is going to start at around 7. There will be speakers later on joining us. Enjoy yourselves, but don't go overboard, because we would like to see you tomorrow at 8:50 in a very good shape. So see you tomorrow. Thank you.